Hey everyone, this is Sean. Today let's think about how to design an AI agent system like a pro. It doesn't matter if you're technical or not, if you're a product manager, designer, data scientist, or computer scientist, does not matter. The goal here really is to understand how do we think holistically about, starting from the front end all the way to the back end, database, and setting up AI agents so that your app will be smarter than just a traditional SaaS product. So today's example is about how do we design this agent system for the e-commerce direct-to-customer brands, D2C brands, to manage their customer support. So as we know that customer support is a field that traditionally has a lot of human involvement when it comes to things like return products, exchange products, or asking about the status of where my product is when it's being shipped. And for a lot of the e-commerce companies, they probably cannot afford to hire a bunch of call centers or message replying agents. So this would be a perfect use case for them to increase their response rate as well as improve the satisfaction for their customers. So now let's jump in and think about how do we think through this step by step. Okay. So the first thing is that our goal today is that we want to make sure that we will have over 70% automation in this customer support flow, which means that the other 30% will probably be we're going to loop the humans back into the conversation when an e-commerce site is talking to a customer, right? And also we want to make sure that the customer satisfaction rate, CSAT, is greater than 4.5 out of 5, right? And last but not least, we want to make sure that the response with the 50% of the percentile of the customers is below 1 second, and then 95% of your customers will get a response under 2.5 seconds. Why is this important? This is important because if the response time is too long, it really affects your satisfaction from your customers, okay? So this is our goal. And let's also think about what is our scope today. Our scope is very simple. We want to focus on returns, exchanges, and where is my order, okay? So let me just delete this flow and then let's walk through it together. So firstly, let's think about the rules of this scope. In order to return to the customer, we need to make sure that the products, for example, will only be returned if it's bought under 30 days before. And it must be returned in good conditions, right? Otherwise, the AI agents probably will just allow any products to be returned at any time, which is not what we want, right? The second rule we think about is how do we think about the refund policy, right? In this case, most companies probably have a refund policies. For example, if it's under $50 and if they're using a human call center as a service, then they will automatically let it to return the product. But if it's over or equal to $50, then they probably need to loop in their manager. We want to mimic the exact user behavior here. The third one is called exchange policy. So if a customer want to exchange the product, they also need to make sure a few things. It needs to be in good conditions, and certain categories of products cannot be returned because, for example, if it's food and you already open it, you cannot really return it, right? And lastly, how do we route back to a human, right? And there could be all sorts of scenarios here. It could be because the user directly asked that they want to talk to a human, or we have detected that there's some very negative emotions in the chat, so that we must involve a human being to basically provide emotional support for the customer, okay? From a backend and database perspective, there are a few things that we should consider in this case. Let me just paste it right in. The first thing is that when and how much is the peak for requests per second, and about the seasonality as well. Imagine this is Black Friday or Christmas time, then probably there will be a lot more people doing online shopping versus the other period of time of the year. And also we need to think about how we're going to store all the chat history, information about the transactions, about return and logistics. Do we store it in a relational database, or do we store it in a vector database? So here's a concept we need to introduce for AI agents, which is vector database. What it really means is that traditionally, we basically define data tables in, imagine you have an Excel sheet. There are rows and columns. Every column means a different feature. Every row means a different entry, right? But in order to search some of the, say, unstructured data, like the return policy or refund policy, these kind of things are not going to be stored in traditional table format. They're probably a paragraph or a PDF, right? So the way to do it is that we can store this information in a vector database in which we will embed each word or each paragraphs into vectors, right? So what we mean by that is that we're going to turn these words into numbers that are in high dimensions. If you're really not from a technical background, just think of it as like, we got to digitize something. Like if you're looking at a photo on your iPhone, it will be stored in digits. And then when they're stored in digits, you'll be able to search them by calculating some similarity between photos. Similarly here, we're allowing it to calculate similarities between vectors, right? So given this current scope, the goal, the rules, the backend database, let's jump in to start designing the AI agent system here, okay? The first thing we're gonna do is that we need to think about when will a user start to interact with our system, right? So in this case, our user channels are going to be website chat and emails, okay? So if you think about this more holistically, we're not going to directly allow anybody to start using the system. So we're going to start doing some authentication first. So here, we're going to introduce a gateway. A gateway is going to deal with the authentication, single sign-on, or PII, which is for privacy of the user. Or you're going to think through the rate limit, like how many times people can actually use this product, request for this product, and checking for duplication. So all these kind of things are sort of, we need to double check with the gateway. So let's add a bit of arrow to confirm this relationship. Before we continue to process any information, we need to finish the authentication first. And also, in order to load the previous chat and emails, we need to query our data from a relational database. Remember, we talked about the rectangle data tables. So what happens here is basically user auth fetch the chats and emails. Okay, we're going to start think about how would the agent help with talking to these conversations from customers. Okay, imagine a customer has just asked a question. Ask a question. They said, I want to return my product X. You probably would think, hey, okay, let me try to check my policy. Let me try to understand what do I do next, right? So exactly for AI agents, the first thing we do is that we're going to introduce this thing called a router agent. What it does is that it's trying to understand the intent of the question so that it knows what to do next. A router agent, there we go. So this router agent will try to understand the user intent and then decide the agent routing. Remember that one of our goals is that we need to make sure that the response time for 50% of the users is always under 1 second. The way we do that is that we need to introduce another agent called a Q&A agent. What this Q&A agent does is that after you get the first question, I want to return my product X, you want to allow yourself a little bit of time for the router to think through it. Right? It depends on the exact situation, like how many steps it's going to happen right after the router agent. You want the conversation to flow like natural. So perhaps after you ask the first question, it will flow into the Q&A agent, and then that will start to speak to the user all the time. And they'll probably start to respond to the user by saying something like, oh, thanks for asking the question. Let me just check it for you. And then start showing them like a thinking process. Respond to the user real time. Okay, so here for the router agent, let's think about the edge case first, right? If the router agent realized that this customer is very angry, like the customers say that I must deal with, like, or they ask a very, very complex question, and we think that our agent decides that it's way beyond the confidence that I have to deal with myself, we need to have a mechanism to allow it to trigger looping the human back into this agentic system so that the humans will take over, so that our overall customer satisfaction rate will not be affected, right? So I'm just going to add in this human in the loop. Oh, this is so difficult to use. So now, in this case, the human will start to approve or disapprove any request from the users. If the router agent decides now that this is a valid request, and let me just double check if it fits with our policy so that I will process the rest of the steps for you, then we will allow it to move on to the next step, right? So the next step, we're calling it a planner agent. Let me just move it back here. Decide to take the return route action. So what happens now is that because the router agent understood the intent, which is to return the product, then it will start to call the return planning agent. So the planning agent for return will start to process what's going to happen next. A very important concept is called functional calling. So what will happen is that we will prepare a very long list of functions that will be available as tools for AI agents to select from. And I'll show you a few examples, which is, for instance, if the user needs to return, you need to introduce a Stripe API that will allow them to get refund or start paying for another product as an alternative. A Shopify agent, which will allow us to pull in the information about what's the order status right now, and what is the return merchandise authorization right now, RMA, and perhaps for some exchanges actions as well. And also things like, oh, where's my order, right? So we got to pull in the API tool that will check some third-party logistics, 3PL, to understand where the product it is right now in real time. And also, for example, if the user is managing some of their customer relationship information in a CRM system, then they will be able to pull in some CRM APIs to start writing or fetching some deal from their pipeline or create and update some tickets. Okay, these are the tools that we're talking about here. So if we move back to where we were, this planner agent will decide what tool we're going to call. And in this case, the tools we're going to call are the return API, which is from Shopify, and the Stripe API, which is for processing payments, right? The reason why I say there's a bit of a catch here is that this planning agent really depends on the logic for finishing this task. It could be a deterministic workflow as well, which means that we could just use some rules to process the rest of the steps, especially when the steps are very fixed. For example, if we know that the user is just going to return the products, then what we do is basically, okay, check Shopify, right? Try to understand if the product is still okay for return or for exchange, right? And then trigger Stripe API to process all the payments related information, right? So actually one very good practice is that if we can reduce the amount of automation of using agents for cases where it doesn't really need an agent, then your system will be more reliable. In this case, just for the sake of presentation, I'm going to show you how to think through the agentic way of a planner for return rather than the deterministic way, but just a very good thing to keep in mind. Okay, so let's move on. So in order for the return planner agent to function, it needs to firstly check some return policies to make sure that it's actually fitting into the scenario that we're talking about, right? So in this case, we need to finally start looking into vector database, which will include things like frequently asked questions, policies, all these kind of unstructured data that are in paragraphs. So that because it's not easy to search in the table, so it will be easier for us to search semantically using vector embeddings. This process is also called RAG, retrieval augmented generation, right? It's a very fancy word and a buzzword at the same time, but it's important to understand that it's basically just fetching information through a semantic search so that we will get more relevant information about this company's return policy, which the large language model does not even know, right? Because this is a private data, and we want to feed this private data into our AI agent. So I'm also going to paste the policy and guardrails services here, right? So what this one does is they basically want to double check if it fits with the policy, right? So there's a bit of a decision-making mechanism here. Just from a diagram perspective, let's say check policy via vector DB. And then this vector DB's information will go through this policy check. And we're going to say, okay, align with policy. Inform the agent. So this is a little thinking process for the planner agent to go through before we trigger any functional calls. You will need to define very clearly in the prompts for this return planner agent so that it knows that you need to firstly refer to all the checks. And if you realize that one agent is probably doing too many tasks, feel free to split it up into smaller ones so that it will do the exact one thing so that it does not hallucinate. Here we're sort of a little bit oversimplifying the situation, but just to make sure that you define your types and define everything very clearly so that your prompts, your agent will understand what it needs to do exactly, right? So after we finish the RAG check from the vector database, our planner agent finally understood, okay, we need to trigger some APIs, okay? So the first API they're going to trigger is Shopify API. If it fits the policy, call Shopify API for return. And if the next step is about returning the money, then we should also call the Stripe API right here. So after the Stripe API has been introduced, which means that we have finished the money return. So the Stripe API should return the information back to the return planner and say, okay, payment, refund, done, right? After this, the return planner agent should be updating all the context back to this Q&A agent, because this Q&A agent is really doing the conversation with the original user channels, which includes the web chat or the emails, right? So imagine this Q&A agent is just like the central brain or the CEO of the company who needs to do all the communication with their customers. And then the rest of these people are just part of their organization who's doing the task, right? Just that the router agent is sort of at a higher level, return planner is the one that the router agent decides to route to, right? And then you could also route to exchange planner or, where's my order planner, all these kind of tools, right? But after this planner has done its job, what it should do is that you should always update the information or the context back to the Q&A agent, right? So the Q&A agent is like, okay, so return the latest updates, the latest status of return back to Q&A agent to talk to the user. So this can also include situations when the question or the product doesn't fit into the policy for return. In this case, we will also update the latest information back to the Q&A agent so they will be able to talk to the user, right? Respond to the user real time. So you can see that we currently have a pretty solid system right here for the goal we have, right? So what do we still need to do? Few things. Number one is that as an agentic system, we should always be thinking about observability, metrics, and evaluations, okay? Remember our goal is that we need to make sure 70% are automation, 30% are looping back to human, right? And then the satisfaction rate should be over 4.5, and the response time should be this much, right? So what we do is that we got to track the relevant metrics across the entire system to make sure that these metrics are being met, these goals are being met, okay? So that's the first thing. The second thing is that it depends on if this current website or this current client is already dealing with some external, like say CRM systems. Perhaps there should be some automatic triggers as well for us to write back to the CRMs, okay? So we could add something like this here, a CRM system that will fetch, write, deal pipeline, or create and update tickets for their internal team to manage some of the processes, right? So I'm just gonna add a simple arrow here. Okay. Cool, so we got a pretty solid system right here. So again, this is a very simple overview on how do you think about the agentic system from a non-technical background, from a non-technical perspective, but also I know that I have introduced quite a lot of technical concepts here too, but if you're a technical, you realize that there are a lot of things that we're missing out, right? There are a lot of things that we didn't mention. For example, about scalability, about things that are related to like the request per second, seasonality, all these server side of things. I think at the end of the day, if you're a product manager, you will need to discuss with your engineering leader anyways to figure these things out. But you need to have like this basic concept of what we need in order to set up this product ready for production. I hope this is helpful. I hope you have learned something from this. And let me know if you like this kind of format of video. I'm happy to make more. And I'll probably also be making some videos to explain how do you actually build a system like this with code. So stay tuned. If you like this video, like and subscribe and make a comment down below. Thanks very much. Cheers. Hey everyone, this is Sean. So today let me show you how to design and build RAG like a pro. RAG is basically retrieval augmented generation. It's one of the most important concepts in AI system design or for AI agents. And a lot of people who watched my previous video about AI system design really asked me to dive deeper into these kind of concepts. So today, we're really going to dive deeper into what exactly does RAG work and what exactly is a vector database. And I'll not only show you something like this, which is a system design to think through how do you build or design a RAG system, but also I'll show you some live code, which I'll open source on GitHub. So feel free to check out my GitHub repo. I'll also show you how to deploy it to a Google Cloud platform, GCP, so that if you have a front end, you can just connect it into your app and start using it right away. Okay, cool. Let's jump right into it and start. So I've got the system right here, but I'm going to just walk you through it real quick. And if you already know what RAG is, feel free to jump into the coding part. First, let's imagine you're a user and you have a user channel. You either talk to customer support with web chat or an email. And then let's imagine here we're using the same example as the last video, which is a customer support for an e-commerce website where you're going to ask questions about certain policies about the company. And let's imagine like the user has asked a question and that question is speaking to an AI agent. We have an AI agent that will speak to the user interface. So let's say the user has sent a question, ask a question to the AI agent, and then the AI agent is supposed to respond with an answer. The AI agent might not understand when you can return a product for an e-commerce site or a D2C brand because maybe some of the products are over $200 and you cannot just return the money to the user and you must check a certain policy or you must ask a certain manager to approve the return, right? So how would an AI agent know if this is an LLM, it has no access to your private data about your e-commerce site? Then we're going to introduce this concept called a vector database, which will store some of the policies about your company return policy. And also, we will use the system that will do the retrieval to let the agent to retrieve the information from the database and then get informed so that the LLM knows, oh, anything over $200, we cannot just return money back to you. We must talk to your manager, okay? So let's break it down and see what exactly will happen here. So as I mentioned, we need a vector database, okay? It's a vector database that will store things like FAQs, policies, these kind of things. And the way that the AI agent will speak to it is basically a RAG, which is going to check the policy. And then the way that this vector database is built is very simple, okay? So we're going to create a frame here. The first one is that you might have a bunch of original documents, okay? Some of these documents could be in like PDF or it could be like a very long paragraph. So in order for this AI agent system to run very efficiently, we need to introduce this concept called text to chunks or anything, PDF to chunks, so that every little chunk is a piece of condensed information so that we're not like overwhelming the system, okay? Then later, we're gonna need to turn these chunks into a thing called embeddings. So what is an embedding? An embedding is basically an array of numbers in a very large dimension. What I mean by that is that, say, okay, now I'm going to input these words into ChatGPT and then it's going to give me an answer. The way ChatGPT understood it is not like, hey, it processes all the words. Instead, it's processing a bunch of numbers. So every little word that you see here to ChatGPT is probably a 1,000 dimension vector with like 0.01, 0.67, 0.86, all the way until the 1,500 something dimension, okay? So that the machine will understand, okay, so with different numbers at different dimension or at different space, it means differently, okay? So the math is a concept called vector similarity or embedding similarity. What it does is that maybe like the word of, French, Spanish, Chinese, these are all languages. So they're probably similar in higher dimensions in mathematics, okay? But this is not the focus of this video. If you're not technical or technical, doesn't matter, okay? So what we do is that we're gonna use the tools that are already built for us and we're gonna use it well so that this system will function properly, okay? This process is actually called seeding. I'm gonna show you in the code in the real example very soon, okay? So after we did the seeding, you have put your policy into these chunks of embeddings and then feed it into the vector database. What happens next is that because now the AI agent is doing the retrieval augmented generation by referring to the database in the vector database and just searching for the relevant information. We're turning the customer question into embeddings as well, and we're calculating, hey, what kind of chunks are actually relevant here so that we'll be able to align with the policy. Let me just draw this diamond here real quick. We're going to align with this policy. And then we're going to inform the AI agents so that it knows what exactly is going on with the policy. Okay? So this is already a very simple system designed for RAG for retrieval augmented generation and vector database. So now I'm going to show you a real example of how do you interact with a RAG system with the use case of a customer support for an e-commerce D2C brand. So I'm just going to type in the website. So you can see that this is a live link. You guys can try it as well. Now we're landing in this chatbot, not a big surprise, but now we have like 4 documents on the right-hand side, which are all related to the policy of, say, for example, how about returns, how about shipping, the guide of the sizing, as well as the support for contact. And let's just do it one example, which is for the shipping policy, there's free shipping for anything that's over $50. So if I just ask a question and be like, I bought my shoes for $80, can I get it shipped for free? And send it over. Could have chosen a better color, but this is not the focus of this video. This is just the front end. So I say, yeah, you can get free standard shipping since your order is over $50. According to the policy, it's okay, as long as it's below $80. So I'm gonna say, I bought a pair of shoes for $30, which is very unlikely. Can I get it shipped for free? Ask the question, and then let's see what the RAG would say. Okay, it told me your thing is not qualified because it's under $30 for free shipping. There's a $50 threshold. Okay, that's one example. Let's do another example. Let's say, okay, there's a return policy and it says that every item that's over $200 require manual approval for returns and you need to email the company. So I say, okay, can I return the shoes that I bought for $1,000? Now it's doing the retrieval, doing the thinking, doing the similarity search, and it's going to tell me very soon. Okay, yes, you can return the shoes, but since the purchase amount over $200, you'll need the manual approval first. Okay, so you can see that this entire conversation with this chatbot has been strictly following the policies on the right-hand side. And you might argue that, why don't I just like feed these information into ChatGPT? Why do I need a RAG here? Well, you're right. In this case, we don't really need a RAG, but imagine this policy is like, instead of 3 paragraphs for each, it could be 300 pages. Imagine you're dealing with like legal documents or stuff like that. And then that would be a different story, okay? So in this example, we're just showing you an MVP of how it works and how you actually build it and make sure you understand the concepts. And then if you're like scaling things up, there are more things that you need to deal with for the back end, okay? So let's try another thing real quick. Let's say, okay, if anything is over $2,000, then that would need an annual approval, okay? If I save this, and I've asked the question again, I say, okay, can I return the shoes that I bought for $1,000? It told me, yes, you can return for $1,000 as long as you meet these criteria. They're unworn, blah, blah, blah. And since your purchase is under $2,000, you don't need any special approval for return. Look at this, it's like immediate. Once I like update my vector database for these documentations, immediately my app will know what exactly is the policy. How easy is that, right? Imagine you have like 300 pages of policy documents. As long as you edit it real quick, and then database sort of re-embed the entire policy, and your robot knows exactly how to answer your customer questions. Okay, I think this is very convenient. And now let me show you how to actually build it and use it, okay? You don't actually need to build anything. I already prepared the GitHub repo for you. It's open source, completely free. Just try it, okay? So my GitHub is right here. It's got shanshan.chen/YT-RAG. YT stands for YouTube, RAG stands for retrieval augmented generation, okay? So if this is the first time you're gonna touch code, don't freak out. What you can do is that you can just sort of, honestly, you can just like Command A and copy and then paste the whole thing into ChatGPT or into Cursor and ask it to tell you what you're gonna do, all right? But in this case, I'm gonna show you step by step how to do this and launch this as a full stack product. And so that you can like link it to your own project, you can even try it in your own real business, okay? And if you're a business in e-commerce brands, feel free to let me know. Happy to do some extra sessions with you if you're interested in me helping you out with these AI automation, okay? Let's jump right into it. Cool. So what we're gonna do is that firstly, I'm gonna clone the code. I'm gonna say copy this clone, okay? And then I'm gonna turn on my favorite app, which is Cursor. Let me create a new window here, okay? So I'm gonna go into my So I'm going to open my project, desktop, developer, and YT-rag. And I'm going to say, okay, YT-rag, showcase. Okay, create that, open. All right, I just created this new folder in Cursor called YT-rag-showcase. What you got to do is that you're going to turn on this terminal, okay? And then what you got to do is they're going to say git clone and then paste this in. All right? You see? Now you got this open source project, okay? So, how do we deploy this and how do we use this? All right? Let me try to guide you through the README documents. So, firstly, we have this architecture that has an app that has the core service, a core folder that will basically define the configuration and infrastructure. We have the models, Pydantic models, that basically defines what are the data types that are going to be required for every model or every API. And we're going to have a service model, then we're going to have a service folder that's going to deal with all the business logic regarding rags, embeddings, AI agents, all these kind of stuff. All right? And then we have a main.py, which is a fast API application for the backend. If this is your first time to deal with backend, trust me, don't freak out. This is super easy. I'm not from a computer science background. I learned all of this by myself through AI, and you can do this too. And I'm going to show you how to do it. Okay? Cool. So we already did the first step, which is git clone. And now all we got to do is we got to go back to, let me just set this up. Now what we got to do is that we got to go to cd yt-rag, okay, as this said. And then we're going to create this virtual environment. Literally just copy this, okay? Paste it in your terminal. All right, so what this did is that created this virtual environment called vim_yt-rag, and then you can basically install your Python packages in it, okay? So we already have our Python packages ready, which is in requirements.tsx. We're only using these few, all right? And just paste this in. And you're gonna install the packages you need for running this project, okay? And then we're going to need to set up our vector database. In this case, we're using Supabase for the vector database. We're going to use the PG vector. I know there are a lot of options on the market. There's Pinecone, there's Weaviate, and we're not talking about which one is better here. I'm just talking about how it works, okay? Feel free to try other tools if you want to. Okay, cool. Let's get started. So the reason why we need to set up Supabase, one is because we need to set up this place where it's going to store these policies for documentations. Number two is that we need these keys from Supabase so that our app is connected to the database, so that they're communicating with each other, okay? Just follow me, trust me, like, this is pretty easy. We can do this. Cool. So, let me start creating a new Supabase project for us. Supabase.com, okay? If I go to dashboard, let me make it bigger. I can go to YouTube. You can see that I already have a YT-rag. I'm going to create a new one just for this showcase. You can click on new project. And then I'm going to say YT-rag-showcase. And then I just input in my database password. And let's just create the project. I'm going to delete this later. So don't even try to use things here because I'm going to show some keys here. And I'm going to just delete it. Don't try to use it. And you should set it up yourself. Okay? Cool. So now we set up this Supabase. Let's see what's going to happen next. Okay, let's come back to the GitHub. You see that wait for the project to be ready, and then go to settings and get all these APIs and copy them into our code. All right. So I'm going to do it. So go to Supabase. Come over here. I think if I just scroll down, yeah. If you just scroll down, you can see that there's project URL and API keys here, and then we're just firstly, we can see that there is a file called .m.example, all right? We're going to copy this and paste this again, and we're just going to call it .m instead of .n example, so that this is for production. And then we're going to copy the project URL here, click on copy. You can see there's a project URL, replace this with the real one. And then you can see that there's this anon public key, copy that, come here, replace the second one with it. Hit Command S to save it. The third one is the service role key. Service role key is right here. Let's see. Let's go to project setting, and then we can find API keys. And then we can see this service role key. All right, going to reveal it, copy it, come back here, paste it in, Command S to save it. Okay, I'm going to delete all these projects. So if we click back into table editor, you can see that we don't have tables now. We're going to set it up real quick. All right. One small thing is that you can see that in this environment variables right now, there's an AI provider. I'm choosing Anthropic. You can also replace it with OpenAI, right? And then there's also like this OpenAI key, OpenAI embedding model. We're actually using this embedding model to embed these words. Remember we said we're going to turn every word into a 1,500 dimension of numbers, right? And then we're going to use OpenAI. If you're using OpenAI, you're going to use GPT-4o. If you're using Anthropic, you're going to use Anthropic chat model, which is, in our case, I'm going to use 3.5. Doesn't matter. Choose whatever you want, okay? Last but not least, the environment's development and log info is info right now, okay? So what's missing in the environment variable is just I need my OpenAI key and my Anthropic API key, okay? So I'm just gonna paste my own keys here. Here I'm gonna block it. And if you don't know where to find it, you can just literally search OpenAI API key on Google, and then you can just create an OpenAI key, log in if you haven't logged in. Just click on create new keys and type a name here and then copy it, right? And then you're gonna start using it. Anthropic is the same thing. Now we're gonna initialize the database. The way we do that is we have a file called SQL/init supabase.sql. Just do Command A, Command C, come to your Supabase, come to the left-hand side, there's a SQL editor, open it, click in, Command V to paste it, Command Enter to run it. Okay, you see, oh, your Supabase database is ready for RAG. Okay, what did we do exactly? I'll briefly explain. Go to the left sidebar, let me just make it bigger for you. Go to the left sidebar, click on table editor. You can see there's a table here called rag_chunks, okay? Remember earlier we said we need to do this thing called seeding, which we're going to turn original documents into text chunks and then embed the text chunks, okay? Here I'm going to show you how to do that exactly. So for now, you can see this table that has ID, chunk ID, source, where does the chunk come from, text, what exactly is in that chunk, what is the embedding for this text, right? When is it created? That's all. We're just keeping things simple here. If you go to the sidebar and click on database, you can see that there's one table here listed, and then you can also click into functions. Okay, why we're in the functions? That's because if we go back to this, we actually define some functions here. One function is called match chunks. You can just copy this and come back here and then search match chunks. You see, this is basically doing like matching, like doing the retrieval, right? Comparing if your query embedding is similar to the embedding that you added to the chunk, all right? And there's several other functions that we defined. There's also a function called get chunk stats, right? Let's just search this here real quick. Yeah, and you can also click on these three dots and click on edit function to edit things. And if you're familiar with the SQL, you will know what's going on. It's gonna select from the rag chunks and count how many total chunks you have. What are some unique sources you have, and what is the total maximum? And what is the latest time when you update the chunk table? Okay, so this is called Supabase functions. Again, this is not the focus of the video. If you're interested in Supabase, feel free to watch my previous videos on Supabase. Let's move on. Continue. Come back to this. You can see that we initialize the database. So here, one thing interesting to explain is that we're using this thing called PG vector, which is part of Postgres, and is basically a way to save vector database, right? Again, feel free to use Pinecone, Weaviate, or LangChain stuff. All these things work, right? Doesn't matter. You don't have to use this one. Okay, so with the rag chunks table, currently we're using a vector of dimension 3072 dimensions. So that's like doubling of 1500 when I say it. Okay, so now let's move on. Now let's move on. So you can see that I have this thing called test setup.py. Okay, let's come back here. Let's see, where is it? We have this file called test setup.py. So what this test setup does is that I'm doing a few things. Firstly, I'm going to import the modules. Second, I'm going to check the configuration. And then I'm going to start doing the database connection. And then I'm going to start doing the schema validation. And now I'll do the seeding documentation. Look at this. I'm doing the seeding documentation so that we are seeding the documents into our database so that later we can do the RAG query. I'm going to show you step by step, okay? Feel free to just run this doc if you're familiar with this. But if you're not familiar with this, I'll show you what exactly we're going to do, okay? So firstly, how does seeding work, okay? So the main.py is an app/main.py, okay? So this is basically our backend endpoint. what it does is that, sorry, maybe it looks scary if you're not technical, but I'll explain everything as I always mention. Okay. First, you have this lifespan definition. What it does is basically just going to try to connect to the database, initialize the schema, all these kind of stuff. And then we have this thing called fast API. We're defining fast API as this name called app. So anything with app.something, that's fast API. Okay. And then we're going to add this middleware, which is basically saying, hey, localhost 3000, localhost 3001, they're accessible to this backend. Because if you're building like the front end with Next.js, you'll be able to, use localhost 3000 or Vercel as your URL. We're just basically telling the backend that these URLs can access you, right? So that there's no access issues. And then we have a chat interface, which is an HTML. Here we're not using Next.js, we're just using a plain front end, okay? And then what's important is that we can just sort of like start trying things, okay? So what I'm gonna do is that, remember to do source vim yt_rag bin / activate. So what you can do is just, you can type in uvcorn main app -- reload. After we run this, we're gonna get a live backend called 127.0.0.1 8000. Okay, so if I just do command click on this thing, it's going to show me this thing called welcome to RAG AI agent backend version blah 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 blah. Okay, and a quick way to check it is that there's this thing called basically you can check either the health of it or you can do something fun. Like for me, I did like /greet/name so that it will tell me if it actually worked. So if we go to this URL and do /greet/Sean, it's going to tell you, hey Sean, I think you're great. Okay, and if I just greet like Donald, hey Donald, I think you're great. So this is like working. Okay, this is working. And or you can just type in /health, is it? Right? And then it's going to tell you, oh, database connected is true. All right. So now let's move on. So here are the three things that are very important. The first one is an endpoint called the /documents. This is where we're going to save all the documents. Okay. So if you go to the /documents, it's going to return to you what documents you have. All right. So let's try that. So if you do /documents, you can see all the documents we have. And I'll show you in the code where is it. So if I just do double click command default, command C, command F, command V, search, you can see that we imported from this, okay? Which is, where is it? From data /default documents. So from data folder, where's data folder? There we go. Data folder /default documents. So these are the documents for the policies that we're going to input, all right? So we're going to have a policy for return, if you still remember in our app. We have a policy for return, V1, policy for shipping, sizing guide, and support contact, okay? So we have basically this exact same thing. Policy return, policy for shipping, policy for sizing, and policy for support and contact, okay? So if we go back to main.py, so if you go back to app/main.py, if you call the API of the URL /documents, it's basically going to show you the default documentations as I showed you earlier. Okay. Another endpoint is called /seed. What this one does is they're going to take the input of the documentation and then start showing you, hey, we're gonna like turn your documents into chunk ID, source, and text. Remember, this is how we're going to store it in the database. All right. So this API, I'm literally going to show you how to turn these documentation into the database. All right. So what it does is that it firstly split your thing into chunks. All right. Split thing into chunks, and then it's going to show you, and then it's going to run this function called rag service seed documents. You can do command click into this. Sorry. And then it's going to run this function called the rag seed documents. Okay, and then it will get to this the inserted account. So how did the whole thing happen, right? Let me show you. So if you run this API, what it does is that it's going to run this function for you. Okay, let's find out where is this function. Command C, Command F, Command V. All right, we define it in services.rag. Right, we have a folder called services. This is basically where we're going to save all these AI agents, right, or agent-related stuff. So let's go to rag.py. Within the rag.py, remember I mentioned that we have a function called seed documents. What this one does is that it's going to turn your documents into chunks and turn chunks into embeddings. Okay, so let's briefly go through it. We have a function here that said, okay, we're going to use the chunk function to chunk the documentations, and then we're going to embed the documentation using embedding service, which is imported from embedding.py. And last but not least, we're going to combine the chunks into embeddings so that we can insert it into the database. Okay, let's check the embedding.py real quick too. In the embedding, what we do is that you can see that here we have embed text. What it does is it uses this OpenAI client with embeddings to create the embeddings based on the text input. Remember, we already cut the text into smaller chunks, so it's gonna embed every text into embeddings. Okay, I know I say a lot of tongue twisters. Let's just run it and see what happens. All right. So all you gotta do is that if you have defined properly of your default documentations, what we can do is that we can just do test the setup to set up the whole thing. Okay. So come to your terminal. Again, if you are not in your virtual environment, do source venv yt-s_rag bin activate. Okay, and then we're going to do Python test setup. Now it's going to run this setup, and I'll show you what exactly we're doing. So we imported the modules, testing the configuration, did the database connection, schema, documentation, seeding. You can see that it successfully seeded the 4 document chunks. And then it tested the RAG, it worked. Okay, and it passed everything. Okay, so now if we go back to the database, go to the left sidebar, table editor, you're going to see all 4 documentations are here. All right, policy, return, shipping, guide, contact, and you can see where the source is from, and you can see what the text exactly is if you double click on it. Okay, anything that items over $200 require manual approval for return, and then there's this embedding that is 3,000 columns of dimension. And if you do this /chat, you're able to turn it on, and now you have these policies right here. Okay, so this is literally using what we define here. Okay, so let me prove it to you by making this a little bit smaller, making this a little bit smaller, and our eye should be focused on our terminal here. Okay, so what we gotta do is that I'm just gonna say, okay, what is my return policy? I hit send. You can see that here it's running because now it's doing the vector database retrieval, and you can see that it's using Anthropic, all right? And then it did the query processing with 1 citation, so that means it found 1 reference, 1 citation, all right, which is the policy that we refer to, return policy, okay? And I just asked the question again, can I return my product that was $800? You see now it's doing this another retrieval again, and then you see that it tells me since your item is over $200, you will need manual approval for the return. Okay, so now we prove that this RAG system already works. All right, it already works. One more thing I want to show you is the chat. If you click on services/chat.py, you can see that we're currently doing this function called generate answer. What this one does is that there's a system prompt, right? It says that you're a helpful AI assistant for customer support, and there's some important rules. You basically say you can only answer questions for policy, return, shipping, and sizing, and you should, for questions outside of knowledge base, you can just politely reject that, all right? And then we can just test it real quick too. You can say, who is the US president now? Yeah, I apologize, it's not relevant, so he's not gonna answer me, okay? Feel free to play around with this GitHub if you're technical. And if you're not technical, if you follow these exact steps that I talked about, you can set this up for your business. Happy to help you to set up for you if you're interested in this kind of AI automation. And the last step I do is I'm gonna make this live. I always wanna make product live because I feel like that's the final step you do. Like that's the core of building a product. It needs to be live. It needs to be able to be used by someone. Let's do that. Cool. So, what I'm going to do is I'm going to go to my Google Cloud. So I normally use Google Cloud for this. And I already have a project. If you don't have a project, feel free to click on here and then click on create a new project. Okay, but that's not in the scope of ours. So I already have a project. I'm going to go right into Cloud Run on the left-hand sidebar. Okay. And then I'm going to select a project, which is the project I created. And you can see all the projects that I have here. And I already have one called YT-rag, and the rest of them are my previous projects. So what I do is that I first need to commit the code to the GitHub, and then we can connect it through GitHub into Google Cloud. Okay, so let's try this real quick. Let's come back to cursor. And one thing I didn't show you earlier is how to connect to GitHub. And if you're creating your own thing, you can also come back to your folder and do remove-rf git. Okay, hit run. Create a new repository. Okay, and I'm just going to say yt-rag/private showcase. Okay, create the repository. Git remote add. Make sure you navigate your folder into yt-rag, and then git branch name. Okay, let's come back here. Command R to refresh it. Cool, this is good. So now we got this, all right? We got the whole thing. Let's come back to Google Cloud. Let's click on Connect Repo in Cloud Run. Let's set up the cloud build name, all right? And then I'm gonna click on here to repository. You can say yt-rag dash. You can see I have two of them, but I'm gonna use the private showcase, understand, next. Okay, we're going to use this thing called Docker file. Okay, what this one does is basically telling Google Cloud that you need to install requirements.txt. And the main working directory is app. Come back here and just hit on save. Okay, and I'm going to allow public access because it's not a big deal right now. And then if I come back here, there's an important thing called variable and secrets under containers. We need to add the variables here. Select the whole thing, paste it here. Okay, and just hit on create. Now you're deploying the app, okay? So this will be a URL. All right, so now creating the service. By the way, now if you go to your GitHub and if you refresh it, you can see that something's running here, right? Because we're connected to GCP through Docker, right? You can click on the details. You can see that it's in progress. So it's very well integrated. So if you click on view more details on Google Cloud, you can see how exactly it's been built. You see it's very well connected. If you click on this commit thing, it will lead you back to your GitHub for the exact commit. Oh, good. So now we're officially live. And then we click on yt-rag private showcase. You can see we have this URL here. Copy this, Command T, Command V. Good. Guys, this is live. And then let's do /chat. Cool, we got our policies here. So for return, let's say it should become, if anything is over $8,000, all right? If I hit on save, by the way, double click here again. You see, it changed into 8,000 immediately. And they updated this embedding as well, immediately, okay? So this template really works well. Okay, so now if I ask the exact same question again, it's doing retrieval on an updated database, vector database, and it's gonna tell me, yes, you can return it and purchase 1,000, which is lower than 8,000 is fine. This is the end of the video, and I hope you enjoyed it. I hope this is straightforward. I hope this is easy to follow. And again, I would like to hear any feedback from most of you guys. And a lot of people ask me for making more videos regarding, showing you AI agent system design. And people also ask me about deployment, so I'm trying to keep the balance. So let me know if this format of video works for you. I'll show the system design at the beginning, and I'll show you the exact code example, and I'll open source the code on GitHub, and I'll show you how to deploy it. Let me know if this kind of format of content is really helpful for you. I don't think anyone else, I didn't find any other YouTubers or influencers doing this. So I'm sort of also experimenting this myself. And at the same time, if you're a business, if you're running an e-commerce website or D2C brand, I'm running my own startup called automanus.io, which is basically an AI agent system that helps people selling physical products to manage their sales leads. And I'm also open for discussing any AI automation requests or demands from a business perspective. Just let me know. And I have all my social media contacts down below in the description and in the comment section. So feel free to reach out. Hey everyone, this is Sean. Today I want to talk about how to build a strong AI agent system. So recently I've been spending a lot of time talking to customers, investors, and other AI founders. And I've got a lot of quite good feedback on how to build AI agent systems. And not only from how people use products, but also from how people build products. And I think that I have collected 8 of my top experiences that I have collected, both from my own experience and from what I have discussed with others. So as you can see, I've already listed on my screen. I'm gonna walk you through them one by one, and hopefully I'll be helpful for your own product building. And if you're a founder yourself, I think it will be a very good reminder, because this is basically what you're gonna need to think about every day when you iterate your product and launch the next features. Let's jump right into it. The one-line summary that I prepared for myself is that if you wanna build really strong AI agent systems, you basically need to build agents that are example-rich, self-improving through human feedback, and simple for customers, and verbose in natural language prompting. I'll explain them why, and I'll go through them in my list down below, okay? So the first one, I think that's super important, is that smart defaults are more important than infinite customization. What I mean by that is that oftentimes the customers are usually a lot worse prompt engineers than you, because if you imagine you're a user, right, and then you jump into ChatGPT, and then ChatGPT asks you to write some prompts for how they should structure their memories, for example, which is one of the top features why people stay on ChatGPT. You probably will be thinking about, okay, what should I be writing about? Should I say, okay, keep everything that I said about my school, about my work, as some kind of important information? Don't remember anything I talk about, in terms of my family, about my privacy. You need to think about these very deeply. Otherwise, it could be making some mistakes, right? When one similarity here is that if you walk into Walmart, for example, there are 20 or 30 different brands of shampoo. You have no idea which one to choose from, right? And choosing is already easier than typing your own prompt. So oftentimes your customers might not even know what exactly they should be writing if you give them too much control on your prompt, right? And then what you really should be doing is that you want to build a strong defaults that you already know that works in your domain. Say, for instance, if you're building a law LLM like Harvey, and you're probably a lawyer yourself, and you know exactly what you should be writing, right? Let's say you're drafting a new, petition for someone who is gonna apply for a green card in the US. Then the prompts that you prepare will probably be involving the past 10 years of experience that you have, practiced law in immigration law, right? And if you let someone who just, started working in H-1B visa to draft their own agents, it's probably less relevant, okay? So you need to be having a strong opinion on what exactly works in your own domain. And then you also want to keep some black box stability over there, because that's kind of a company secret, but also you kind of don't want people to mess up with it, because that's based on what you have learned in the past, right? And eventually you want to optimize for the outcome of the user rather than something that is infinitely customizable. This is actually a feedback that I got from one of our investors, and he basically suggested that, hey Sean, when you're building these AI agents, make sure that you brought in a lot of your own experience, which in my case is that I used to work at Google Business Messaging, where we enabled more than 10 million businesses messaging directly with their customers. So now we're building something similar. We're building something that allows all these businesses to chat with an agent, allow their customers to chat with an agent, eventually turn these conversations into structured leads. So we are going to embed a lot of what we have already known about this industry into our agent. So that is why I got this feedback, which I think is super valuable. Okay, move on. Next one. Number 2, meet users where they are. Don't change how users work today. Basically, it means do not force people to change their behaviors. Imagine, I don't know, if you are a left-handed person and then I ask you to play tennis with your right hand. Maybe that's not a good example, but just imagine you're terrible at playing tennis with your right hand, right? And then I ask you to do that. It just doesn't make sense. The better way to win a game is basically, as a coach, I would try to assist you with your left hand playing tennis, rather than telling you, hey, right hand is much better because everybody's doing this. We have this new tool. Don't do that, okay? And especially if you're building a B2B SaaS, what you're not going to be able to avoid is that most of the customers are probably using Google Sheet or Excel. or spreadsheets, right? And a lot of the startups, if you're targeting startups, are using Notion. So what you really need to think about is that how can we build our agent flow around these existing tools, right? Follow those familiar patterns rather than forcing a complicated new view for the users. And I think that's incredibly important to keep in mind all the time, because as founders or as product builders ourselves, it's very easy for us to sort of fall into the product I built, because I feel like, oh, this is this beautiful thing that I created. But in reality, your user might just feel like, okay, I see a new dashboard, I see a bunch of new like features, they look very smart, but my entire company's data live on Google Sheet. And if you don't adjust for the workflows that your customers are already using, like spreadsheets, what you're going to end up with is basically their budget will be spent on your product for maybe a year or a quarter or something, and your product just left there and nobody's touching it in the company, and eventually they will stop renewing, right? So that's not the situation that we want to be in if we're a B2B founder. So yeah, that's why I think this is super important. And the third one is basically vertical first strategy. Okay, so this one is also advice that I received from one of the investors I spoke with. They basically were saying that the most effective way for a founder to start expanding a product is that you want to build these agents around a very specific vertical and really, really double down in it, right? And then what they're saying is that a very high volume, detailed, domain-specific examples will make the model stop doing stupid stuff. Okay, so this is actually another AI founder friend that I spoke with also told me about this. Like, he would rather put like 20 or 30 examples of exactly how an agent should be interacting with the user if it's a chatbot, or how exactly an agent should be dealing with some like JSON files or PDFs or stuff like that, so that it will actually know, like putting these 20, 30 examples in so that it will actually know how to behave and perform in specific situations. And because that you're very specific and you're in a very specific vertical, what happens is that your agents will be feeling like it's doing one thing at a time, right? One thing that's really, really that's really, really special about LLMs is that it's like a generic expert. It knows everything. And especially these days, a lot of LLMs are using this mixture of expert kind of model, kind of architecture for their LLMs, meaning that they know many different domains. Therefore, they're like experts in many different aspects of life. And you need to tell it that, hey, your job is simply to be the expert in this one thing and this very specific expert of this vertical. And then you'll perform so much better than, like, say, doing it in a horizontal level, like from the beginning. Okay, and then later, if you realize that there's a product market fit in that domain and also your agent is doing a really good job, you have two ways. You either like double down on it, and if it's a big enough market, then it's already a venture scalable business. And if it's not, then you can think about expanding horizontally, right? You can follow the same architecture of mixture of experts, meaning you could build a mixture of vertical agents and let them deal with very different things, right? So I think that's a very helpful advice to keep in mind, because as builders or as product founders, it's very easy or common for us to think that, hey, LLM can answer any questions, let me just use one agent for everything. I don't think that's the best practice in reality. Okay. Number 4 is that examples need to be carefully balanced when you feed examples to the AI agents. Basically, if you use too few examples, then the model would think that there are only a few ways to solve the problem. You might actually restrict them. And if you have too many of the wrong kind of examples, then the model might overfit to some bad patterns. And this idea is very similar to how we were approaching machine learning about the data sample size and about the parameter size, right? But in the LLM world today, it's more about how do you like structure these things in natural language and then provide them with a good balance of very solid examples so that your agents for this very vertical will be able to understand how to solve that task. Number 5 is that you need to write the workflows as explicit natural language specs. Okay, so basically what I have gathered throughout the information online is that multi-line, step-by-step natural language instructions will minimize hallucination and give an agent stable, predictable behavior. Okay, what we mean by that is that sometimes we might just want to throw a table to LLMs and say, okay, read this or do this and that, right? Or maybe we might throw a bunch of files to it. We might just give it, if you're more technical, give it a bunch of JSON. What turns out to be more effective is that if you can explain in natural language, okay, here's the first step, you should be doing A, B, C, D. And then if you see this, do this. If you see that, do this. And then the next step, do this. And under what situation you should be using this tool, that API, this tool, right? And here's the explanation of these toolboxes. Like use the Stripe API for payments, use the Supabase API for fetching data, under the situation where, if this person has authorized, yada, yada, yada. You want to treat them as like an intern in your company, or as, like if you're a product manager, as if you're writing some product documentations. You don't want to just throw a doc at people. You want to explain to them exactly what they should be doing, right? So somehow I think LLMs pick that up from human beings, and also because it's a language model, right? So explaining in words and explaining them in very structured, concise manner with logic and with experience really helps with the performance of our AI agent system. Number 6, add human in the loop correction loops. Have some kind of approval rejection cycles so that it acts like a micro training rounds, right? So if you have some good correction and then you have good improvement, and then your stability endures for longer, okay? I think this one specifically applies to customer support, which is, these days people call it CX agent, customer experience agent. There are a lot of examples out there. There are Fin, there are Ada, there's another company called Sierra AI. They provide a very strong customer support, customer experience agent services out there. What they normally would always have is that there's a way to trigger humans to be looped in. Say, for example, DoorDash. If DoorDash is using some of these like AI agent services, there's always like a team being maintained right there who are going to type in like answers to customers. And when we build these AI agent systems, we always want to automate the whole thing, but that's not the reality. In reality, customers would be like, they would just directly be requesting for a human to be looped in, right? Or a customer might be, super angry, and then agents are still talking like a robot. In these kind of situations, what you should do to maintain a good customer satisfaction score, or just for your own retention's sake, you should loop in humans at that point, and then you should have some kind of mechanism to trigger that. And also, you should train on these good and bad examples so that your agents in the future will understand, how would I address a situation where customers are super angry, or when they're requesting for a human, or how do we reduce these situations? These are super important lessons to be learned, and it's very important to be mindful of that when you write prompts. Number 7, give your agent a single memory layer. I think this is more or less related to context engineering across a multi-agent system. What this means is that, so for example, if you're building a SaaS where there are a bunch of agents, for example, I think now we're using Notion, right? In Notion, there are agents. I'm pretty sure what they're doing is that they have a multi-agent system. Maybe there's some agents are just for, polishing the paragraph you just wrote. There's some other agents who are like reading the entire doc and then give you a summary. And then if you're like on the same page and you're talking to one agent, or you're doing like multiple things at the same time, they should, I'm not sure, Ivan, tell me if you're watching this, they should keep one context layer somewhere so that every agent will have access to the historical usage of agent in the entire system, either it being chat history, being how like Sean highlighted something and then asked a question there, what's the context there. These things will be considered as a single memory layer. Or, you have data tables there, you have calendar events. If you're like making a tool that's helping people to schedule meetings, or having a voice agent that will, schedule meetings, book appointments for dental offices, stuff like that. Having a single memory layer is always super important, because that just simply solves the problem of, some parts of your product just don't remember what the user did previously, right? And if you're, say, for example, if you're like building an email agent, then this email agent should have access to some sort of calendar events that you previously scheduled for them if you have another voice agent right there. Okay, so it might sound a little vague if you haven't built these things before, but if you did, then you will know what I'm talking about. If it's the first time for you to hear about what is a memory layer, try to check out things like how do you build up some context, how do you build up some shared states for agents. Search these things up, and then I'm sure AI will give you a really good answer as well. Last but not least, which is something that YC partners would emphasize all the time, which is evals. It's important to add a continuous evals to measure and enforce reliability. Okay, so what in reality, agents regress very easily, and automated evals across workflow scenarios and edge cases ensure improvements are real. Let me give you an example. If you say are building an email agent, and this email agent is supposed to check the headline, check the subject, check the content, make sure you have the right signature, make sure that it read the previous context and mention anything as a greeting, like as context that you know how to greet this person if it's a follow-up. And then what happens is that sometimes agents might skip the steps. Depends on, today maybe Claude is not performing well, tomorrow ChatGPT is like replacing their old model with some updated ones. Anything could happen, right? So what you should do is that you kind of have to have the system there to do the evaluation and be like, okay, before you hit send of any new emails, make sure you check that each one of these steps are fixed or are like fulfilled. And you have some kind of like code there to make sure that it's actually, filling in the information requested, right? Before you send the email. That's kind of the eval system, a very simple one that I could come up with right now. And having these evals that are very specific to your own agentic system or your own agentic workflow is kind of one of the most important moats out there for AI startups or AI products, because you know your product, you know how to make it better. You also know that this is not going wrong because you have this very, very strong like security system or stability maintenance system out there so that your agents do not regress, okay? And I forgot to mention another very important one is a single memory layer, which is, that's honestly one of my founder friends recently just said that he's now switching to Gemini, even though Gemini is really good. And the reason is because ChatGPT has got his entire past 2 years of history, and is more comfortable just talking with ChatGPT because he doesn't need to explain again what his company really is, what was that last contract they just signed, stuff like that. Okay, these are super important moats for your company. Last but not least, LLMs are super capable. If an agent messes things up, it's almost always your prompt's fault instead of the model's fault. So this is coming from one of my founder friends' quote. If Claude can learn code bases, can learn how to write code, your agent has no excuse. You should give them as much of an example as possible. And the example was that Claude leaked their prompts out there, right? So basically, they just put a ton of examples in their coding tasks. That's why they know how to write code very well. Okay, so if Claude can learn code base, your agent has no excuse. Your agent should be better prompt so that it does exactly what you want it to do. Okay, so I know I've been talking for a long time, but let's come back and recap this. Essentially, if you want to build agents, AI agent system that is very strong, what you got to do is build agents that are example rich, self-improving through human feedback, simple for customers, and verbose and natural language prompting. And I guess maybe here, I should probably include with a memory layer as well. Let's just say with a memory layer and evals. Okay. Yep. That's basically a very high level summary of how to build strong AI agent system based on my personal experience, based on the conversation I had with customers, with AI founders and investors. Hopefully this is helpful for you, and let me know if you have any questions. I'll see you next time. Thanks.
Hey everyone, this is Sean. So today let's walk through how to build an agentic RAG system like a pro. We're going to walk through a quick system design over here,
And then we're going to jump right into a live demo that will not only have an embedding in a vector database for retrievals, but we will also show you how to use some tools like setting up Google Calendar, setting up a Gmail. And last but not least, I'm going to show you a open source GitHub repo for agentic RAG that will allow us to set up the entire code base with Supabase, Python backend, and Google Cloud. So let's get started. Firstly, this is a system design for an agentic RAG. For some of you who watched my previous video about a YouTube RAG system, this is basically an extension. We introduced this new thing called agentic tool. The user will have a user channel that will either talk through a web chat, an email, or a WhatsApp, and eventually it's going to interact with an AI agent that sort of is doing the communications over there, right? And then according to our previous video, we basically allow this agent to query some data from a vector database, which in our case, we're using Supabase. And this vector database essentially is like splitting some original documents, turn them into smaller chunks, and then turn those words into embeddings. Embeddings is basically a high-dimensional vector that will represent words in numbers. Eventually, this AI agent will sort of check the policies, check what kind of products they have. That's the traditional RAG we're talking about. Today, we're going to show you this very quick demo of talking to an AI agent and actually letting it schedule a call with us and eventually sending us an email. And I'm very excited to show you the demo right now. This is a localhost 8000/chat. And let's just jump right in and see what happens. And you can see that currently we have this thing called a scheduling time zone, V1. I sort of set up the time zone for availabilities for this AI agent to respond to a consumer. So if I say, I want to schedule a call with your manager to talk about a wholesale deal, let's see what it says. All right, now firstly, it asked me to schedule a call. Before that, they asked me about the preferred date and time for the call. And I'm just gonna say, okay, can we do 6 a.m. EST tomorrow? Now, ideally, it should check the policy over here, and it say that the earliest available time slot is 7 a.m., which is true, 7 a.m. right here, okay? So it cannot allow me to schedule time. So let's just say, okay, cool, let's do 10 a.m. EST tomorrow. My email is sasha.ru@gmail.com. And meanwhile, let's just show the calendar right here, okay? Let's send this. Cool, so now it has set up the call for me. You can see that it popped up real quick immediately, right? Look at this, it's already here. Sent from Sean at automatis.io. Automatis is our startup, by the way, which is a sales leads manager for made-to-order products. Feel free to check it out, automatis.io. Send me a summary email as a heads up. So you can see that in my mailbox, I already received this calendar, and I can say yes to it. And if I come back, I just got another one saying that it's a reminder for an upcoming call, which is literally what we asked for, okay? So this agentic tool calling is working. This is incredible. What happened was that we asked, can we do 6 a.m.? And then it checked the policy. They said that no, 7 a.m. is the earliest time. So it didn't even do the tool calling. And then later I say, okay, let's do 10 a.m. tomorrow, and immediately understood. And I gave it my email. And then it also, let's see, you also know that we're doing a wholesale deal discussion. So it also has the context. And eventually I asked it to send an email as a heads up. It also sent me an email as a heads up. So this is a full cycle of a agentic RAG system that allows this AI agent to talk to a consumer, okay? So now let's jump right into the code and see how it actually worked. So I prepared this GitHub called yt-agentic-rag under Shenshong Chen. You guys can all have access to it, github.com/shenshongchen/yt-agentic-rag. I'm gonna link the YouTube link here. If you like the video, you can click on Buy Me a Coffee to support us. What I really wanted to show you is this current project setup. We set up this agentic system in a fast API backend. Just like previously, we actually had another repo called yt-rag. Let me just turn it up for you. This is yt-rag, got 33 stars so far. What this one did was simply vector database for the RAG, and there's no tool calling at all. And this time we're going to dive into how do we combine both of them so that the AI agent has access to not only the knowledge, but also the actions, okay? And you can see that we have a comparison here that previously we also have vector search and RAG for Q&A. But this time we're getting tool calling, agentic reason loop,
calendar scheduling, email sending, multi-turn chat history, multi-step actions. So if you scroll down a little bit, you can see that there's a step 1, and then you basically just git clone this repo and set up some Python environment. All you gotta do is just copy this, turn on your Claude Code, Cursor, VS Code, whatever. I use Cursor, so let's try the Cursor version. So all you gotta do is you literally just find somewhere empty and then paste this whole thing in and then hit enter. It will start a new project for you. And then the next step is that you need to set up your Supabase. Basically, for anyone who's not familiar with it, Supabase is one of the most popular AI agent related database. And then they also have their own vector embeddings for retrieval augmented generation tools. So it's very handy, very helpful. You just gotta create a new project, set up the password, set up a new region, and all you need to do is to copy these APIs and the project URLs. And if you go back to the code, you can see that we got this .m.example. What you need to do is that you need to copy this, turn it into a .m, and then replace these Supabase URL, anon key, and service row keys with the real ones, okay? I'll leave this to you guys, and feel free to check my previous videos for how to set up Supabase. I've got plenty of examples. So after Supabase, there's another thing, which is you need to set up the database. In our code, we have a section called SQL, and you can click on Initial Supabase SQL, and you can see that we're showing you how to create the tables. All you gotta do is just Command A, Command C if you're using Apple. Come to Supabase, come to SQL Editor, click on plus, click on New, and then just paste it here and run it. That's it. And then you're gonna set up the tables just like me, all right? On the sidebar, table editor, you can see that I was showing you the example of the policies, and all of them, we have some initial setup just for you if you run this project. After you set up the Supabase, what happens is that you need to also set up the OpenAI keys, and then eventually set up the Google Cloud, because we're using Google Calendar and Gmail, so it's gonna be much easier. So what happens is that you need to set up this thing called a service account. What the service account does is you're basically telling Google that this app is allowed to use my Gmail to send calendar invite to this extra Gmail externally, okay? And then the way you do that is just, you need to come to console.cloud.google.com/API/credentials, or you can just navigate to the left-hand sidebar, API and services, and click on credentials, okay? And then you'll be able to land on this page where you can click on create credentials plus a new service account, okay? And a service account is basically you can handle everything in the back end without any authorizations anymore. It's just, you're giving it your secret or access to a project, okay? So you just gotta put in your account number, account name, and then put in a new ID, and then put in the description, and just follow the instruction and finish the whole thing. I have documented everything here, so you just need to literally follow this step. Right, give it a name, agentic rack service, and then eventually you need to download the service key to your local folder called credentials/serviceaccount.json, which is right here. We have a folder called credentials, you can see. You need to download that key over here and call it service_account.json. Okay, that's all you gotta do. And if you're deploying this to Google Cloud, you also need to set up something else, all right? But other than that, you just need to make sure that you entered this OAuth scope into your Google Client ID, all right? And then just authorize the whole thing. And then you just need to set up the environment variable, and that's about it. So in our code base, we have an app folder in which you have the agent folder, and then our main agent is over here called Orchestrator, okay? I'm just gonna keep the file, which is all the changes. And then what this one does is that this is the central agent that will help you to retrieve relevant context from the rack and build a message system, doing the functional calling, tool calling, and eventually generate the final response with the output, okay? And then this one is being fed with the tool folder, in which you can see that we've got, for example, this calendar tool, okay? This calendar tool basically has an automatic Google Meet link generation, multiple attendees, time zone support, RAG-informed duration. For example, it's scheduled 30 minutes because in our policy it said 30 minutes, okay? So this is very handy. And then in the service folder, we also have the rest of the things, just like the previous video, where we basically tell the agent how to chat, how to chunk the documents into smaller chunks, and how to run the embeddings using OpenAI. This demo is literally focused on calendar tool and email tools, all right? And for the calendar tool, essentially it's a new service account that you created using Google Cloud, and eventually you're going to execute it by sharing, exactly what's the start time, end time, description, attendees, and time zones. Okay, feel free to play around with this repo. It should be pretty handy for you already. Hope this makes sense. Let me know if you have any questions. This is probably one of the simplest agentic RAG system, full stack from system design to code to deployment on the internet. Let me know if you have any feedback, and I'll see you next time.
Hey everyone, this is Sean. So today we're launching Automanus AI agent for businesses who are selling customized goods, ranging from cabinets, solar panels, EV cars, to module-based softwares. So a lot of businesses we're speaking with are either qualifying their customers through WhatsApp, SMS, or emails. Many of these businesses are talking to 20 to 50 customers at the same time. And maybe like 20% of them would actually convert into a final conversation and then turn into actual leads. So a lot of time are wasted on qualifying the customer and eventually manually typing things into CRMs. So we're going to change that. Okay, so today I'm going to show you how a consumer would interact with Automanus WhatsApp agent. And then eventually we will configure the agent and then turn it into a structured leads. Let's get started. So essentially, as you can see, that firstly, we ask this question. I say, hi, hey, this is Sean, how are you? And you say that this is the Automanus AI receptionist. So on the right-hand side, you might be wondering what's going on here. This is an agent that we trained for this specific business, and it's called EV Dubai Ltd. Okay, so essentially, this is a customized page where you can do some multiple choice questions, and then you can talk about like what restricted topics there could be. What you need to do is that you need to tell it, okay, what kind of products are you selling, right? For example, this EV brand is selling BYD Seal 2025 and then Tesla Model Y with their own price. And then you can just quickly test it here and be like, do you have BYD models? And this simulator will be syncing exactly what you have uploaded to your knowledge base, as well as the things that you have updated on the main behavior guidance training page. All right, so now you say that BYD Seals has $42,000 USD, okay? You can also modify the formality and if you want it to be calm or more passionate. Eventually, you just gotta click on deploy. And eventually, if you come back to overview, you can see that there's an agent currently being deployed under this AI agent hub. We're using the shared number +1 650 605 6956 for Automanus. If I just ask it questions and be like, okay, do you have a BYD model or an EV? I want to buy one. Right now, Automanus doesn't know who you are and who you're looking for, right? And then after you show the intent, it's kind of sort of processing and then search across the entire business's network that has been connected with Automanus. And it found out that, oh, there's a one called EV Dubai Ltd, right? And as a user, if I click on it, what it does is that it's going to trigger this agent for me. If I want to exit anytime, I just type exit anytime. In our knowledge base, we have these products here. So I'm just going to ask it, can I buy the BYD Seal car? Do you have a model and what is the price? So as a business, you might have these kind of questions maybe 1,000 times every week, right? And then what you don't want to do is that you don't want to answer all the questions again and again. And maybe you want to configure your own way to answer these questions, which is all doable in this behavioral guidance page, all right? And now it has told me that, okay, the BYD Seal is available, which is $42,000, exactly what we put in the knowledge base. And what we need to do is that, yes, my budget is 50K. Let's get the BYD Seal model for 52K. I'm just being like dumb and answering things very thoroughly here. And while this is being communicated, as a business, you can also come back to leads on the left-hand side. And you can see that there's a lead pending in the review, okay? And if you tap on it, you can see that Sean Chen just had a recent journal with WhatsApp with us, okay? If I click on view all, you can see that the entire conversation is here, all right? So as a business, I could approve this as a lead and then let my sales rep pick it up, or I could just cancel it out, right? So today I'm gonna approve it. So if I click on approve, and after you approved it, it's gonna land in the in progress lead. Okay, so you can just always come back and check that this lead is active. Then what if somebody has followed up and they say, I also want to buy a Tesla Model Y and I can double my budget. What you will be able to see is that there's an additional appending review for this new chat that just happened, okay? If I just say approve, again, you can see that the new conversation has been merged to the existing deal with Sean Chen, all right? If I come back to in progress, expand it, you can see that there are 2 conversations at the same time for the same customers. And I could also just click on extract to-dos. And after that, if you cross it out, you can see that there are a bunch of to-dos here related to the conversations that the consumers had with the business. And it's just super convenient for you to handle, say, multiple conversations at the same time. Okay. And then you might be wondering, okay, we're using this shared WhatsApp number. What if there's another company? What if my business want to sell something different? This account is basically selling cabinets. All right. And this agent is basically selling cabinets by a different company. All right. And if we click into edit, you can see that there is a cabinet hero agent over here. As a consumer, I could come back here and I say exit, and then Automatis will tell me, got it, you've been disconnected from EV Dubai Ltd. What business do you want to speak with today? Just tell me your company name. We can just let the consumer to talk to WhatsApp with your business name. Or as a consumer myself, I might be just wondering, okay, I want to upgrade my kitchen with a very vague intent. And the agent that's talking to us right now is the AI receptionist from Automatis. And they said, okay, the kitchen upgrade really transformed your space. Are you looking to replace cabinets or do you want specific areas? It doesn't tell me exactly what business yet because it wants to collect more intents from the consumer. And I could say, okay, I want a new cabinet. Do you know any business selling it? I might need to scroll down for this chat every single time. And now you reply that, okay, we have this company called Queenswood, right? There we go. Queenswood is right here. If I click on Queenswood, it sends this message back to Automatis AI agent. And again, we're connected to Queenswood agent right here, right? So I just say, do you have any discounts? And if I come back to knowledge base, I have already uploaded a 20% off discount for the Screen Slim Shaker cabinets. And you can see that immediately knows the context that the 20% off is for this specific product. And I'll just say, I want this. Okay, click on send. Meanwhile, if I come back to leads, I click on pending review, you can see that there's a new conversation here. If I expand it, I also have a WhatsApp conversation just like before. Similarly, I could approve it from a different business, right? Once that business has approved it, it has nothing to do with the other business. So we're sharing the same number over here that allows any consumer to, if they want to buy certain things, they just literally explain what they want to our Automatis WhatsApp agent. Eventually, if the agent that you deploy is connected to it, the conversation will land in your leads, in the pending review, okay? And after you approve it, if you have clearly explained what product you want, then it's also going to capture the product that the consumer was interested in. So the way to set it up is actually really simple. You just come to the landing page of automatis.io, and then you can either try it by clicking on the chat with us down at the button here and start conversation, open WhatsApp, and then just send the message. It will be able to trigger the conversation. Or you can come back here and click on start free trial. We're providing a 30-day free trial for the starter package for $20 per month. If you click on it, and we're already subscribed, so after you subscribe, by the way, it's completely free for 30 days. You can cancel at any time if you want in the settings. 2 last things. If you're interested in setting up your own AI agent, you can also click on connect your own WhatsApp and then connect your WhatsApp over here. All you gotta do is just put in your access token, phone number ID, and business account ID, and you'll be able to set up AI agent for your own. Let me know if this is helpful. If you're a business who are selling customized goods, either physical ones or softwares at scale, we're very happy to talk to you. And just email us at hello@automatis.io. Thanks for your attention. I appreciate this, and see you next time. Cheers.
Hey, Cloud, can I create a sales representative agent for my business? Yes, sir. Let's go. Every AI product and agency business needs a way to talk to your customers. And it does not matter if you're technical or not, you don't want to build this from scratch every single time. What you really want is a sales layer that will be the sales interface to speak to the world. And that's why we're introducing Automatis MCP server and API services for you today, because we want you to be able to create your first sales representative agent within 1 minute. Let me show you how it works. There's a very simple way for you to set up MCP if this is the first time to hear about it. You just need to go to your profile and click on it and then come to settings and developers, and you can see that I have a few MCP servers right here. Notion API is one of them and Automatis is the other one. You can just click on edit config. You see, it will pop up this link here, and all you need to do is follow the instructions on the MCP server development repo here. You just need to copy this,
and then open this Claude underscore desktop config JSON, and then just paste that in. I have multiple MCP servers. You can see Automanus is right here. So as you can see, after I ask this question, it's asking me for three things: company name, website URL, and my email. This is because my Claude code has been set up with the MCP server from Automanus. So let's say the company name is calendly.com. And also I'm gonna provide my email for development. I'm just gonna hit enter. So now you can see that Claude code is gonna sort of, using this MCP server again, trying to create the sales agent for me, for this company, and my email. It's using our backend services to search this website. It could be your AI product, it could be your agency website, to understand how do you take in inquiries from your customers, what kind of things or solutions are you providing for your customers. And the whole goal of this agent that's creating for me is to make sure that there's no leakage from customer inquiries when you're not in your office or when you're out there speaking to other clients. As I promised, within 1 minute, everything has been created. You can test it with two ways. You can either click on this link right here to chat with the agent, but that agent currently is on the system server. You don't own it yet. And at the same time, you must have received an email, which is something like this, which is asking you to claim your agent so that you will be able to own it in your own platform. But let's try on WhatsApp first. You can see in this email, there's a link called test on WhatsApp. If I click on that, it will pop up this WhatsApp link that will allow us to chat with this Automanus agent right here. And just enter, I'd like to talk to Calendly. So it gave me a button to click on to route to Calendly, but you can see this little yellow warning here because that agent doesn't belong to me, right? Because I'm not from Calendly. If you're an employee, if you're CEO from Calendly, you'll be able to claim it using that email link with your own email domain so that there's no security issues. This must be verified by you. What do? All right, it says, I'm here to help you discover Calendly and simplify your scheduling. We help you do appointment booking. How much is your service? Cool, the service is like $10, $16, or $15K a year. We can also ask Claude Code to add more knowledge to it. So I'm gonna say, can you add a booking link to its knowledge base, which is my Calendly? Let's go. So now it's using this MCP tool called add knowledge. All I need to do is just say allow, and then we'll be able to add this knowledge base to this agent, and we can see if it's working. All right, so now it's done. So I'm gonna say, can I schedule a Calendly booking with you? Do you have a link? Cool, it says yes, you can schedule a meeting directly using Calendly link. And if I click on it, I'll be able to book a call with you. All right, so this agent is completely created based on Claude Code MCP, and I think everybody can do it. So now let me show you how to actually claim this, and then you can own it and then can modify all the knowledge that this agent should know. Remember, we received this email. There's a link called Claim Your Agent. Let's just click on that. All right, and now it's then going to direct us to this invite link that will allow you to claim this agent if you use the same email that you used to sign up. Cool. You can see that we have this new agent called Calendly Assistant. And if I just click on deploy, okay, because now we're on a free plan, so you can only deploy one agent at a time. If I click on edit it, so this company is called Calendly Assistant, and we can see that there's goals and actions. It scraped the most important information here, and most importantly, there is a knowledge base that has all the information that we have scraped from this product. Remember, we say the agent was not verified. Now in the training page, you can click on the sandbox mode and then put in your website URL to confirm if your emails match with it. If it does, then it's going to verify it. If it does not, then your agent will remain unverified for security reasons. Now you might be wondering, where are the conversations? You just need to move to inbox and click on it. You can see the entire conversations that we had between the clients and the agent. And what you can do is you can create a lead from this conversation by clicking on the button. So what it's doing is that it's processing this entire conversation, identifying if they're looking for any products or trying to book a call with someone. And then eventually you will be able to turn it into a structured lead. Imagine it could do this in batches, right? If you have like 700, 800 inbounds of inquiries over a month, then you might be leaking some potential customers by not replying to them promptly. With this product, you'll just be able to handle it without much of a concern, okay? So now it's almost done. Okay, you can click on create view lead. You can see leads hub for the entire conversation. In the to-do, you can see that the customer was trying to book a call with us. If you cross it out, you can see this customer is potentially a enterprise customization client, so you capture that the value is about 15K. So this was a quick demo of how you would use Claude Code MCP to build an agent for your business or for your product immediately. If you are a developer, you might not only want to use MCP, but you want to perhaps set it up using APIs. Maybe you're building a SaaS product or an agency product that require a lot of back and forth conversations. And while you're building the website or updating your product in Cursor, in Lovable, in Claude Code, you might want to just have access to the API. All right, we also have that ready for you. You just need to come to settings and API access, and you will be able to create a new key here. Let's just say test key. That will expire in 30 days. Create the key, copy the key, click done. And then all you need to do is just, use this curl. Let's just try it with a real terminal. I'm just going to copy this in and create this company. And now this API is going to create this agent for us. It says it's successful, and in this case, it should just be directly in your agent hub, because you're using the API keys. Okay, there we go. You have this entire agent here using the API. You don't even have to claim it, you just need to sign in first and then create the API key to use the API key to call the API. We're also able to allow you to create a web chat. So if you come to AI agent web chat, you can say, let's say Calendly, and then we can say create a widget, choose a different color, right? Put it at the bottom right of your screen. And then you can just test it right here. It's just like, hey, what is your service cost? Okay, same thing. You can also click on a WhatsApp to chat with the WhatsApp agent. So, this is the entire process of how you would use MCP server or APIs to create a sales representative agent for your business, for AI product, without much pain. And if you're curious about this, I would really appreciate it if you can come to our GitHub server and check out this documentation. And if you really like this product or you just want to support me, give us a star or fork our repo and download our MCP server on here. Everybody will get 100 free credits, meaning 100 free AI-generated responses for your clients. And I would love to hear any feedback, and happy to chat more. Oh, also like this video, subscribe if you can, and we have our Discord server down below in the link. Happy to discuss more in our channel on Discord. Thank you so much, and have a great day. Hey everyone, this is Sean. So today we're going to go through probably the biggest buzzwords in AI agent system recently: agent harness, loop engineering, LLM ops, which stands for large language models operations, eval, which stands for evaluation system for AI agents. And these things become popular or become viral on the internet, not because they're just some really complicated concepts. Instead, they're actually very simple. And I believe that simple building blocks will actually help us build the biggest architecture in the world that will function like an intelligent system. Let's walk through this step by step, and it does not matter if you're technical or not. We're gonna go through this, and we'll make sure that you're equipped with the right knowledge for prompting your way through building such a system in the future. Let's jump in and get started. For those of you who have watched my previous video on AI agent memories, you're probably already familiar with this chart. This is an AI agent run, which means that it takes an input from a user prompt. For example, you're asking ChatGPT or DeepSeek a question and say, hey, when was Sam Altman fired from OpenAI? And then it's going to go through the entire run, but the end goal is that you want to get a response. This is actually ephemeral, which means that there's no memory in this at all. We're sending that question, when was Sam Altman fired? And any chat history that's currently in the chat. For example, maybe we had some conversations before that, which for example could be, you should talk to me, like Elon Musk grilling on Sam Altman because they don't like each other. And then these things will be fed into this thing called a working memory or a context RAM. In this video, we probably won't dive too much in depth into the memory system because there's a previous video talking about it already, but I'll just quickly go through it and then we'll introduce the concept of what a harness means. When you have this kind of short-term working memory, there will be an LLM or a large language model which performs as a question and answer agent, and at the end you're going to get a reply. But the problem with a simple agent run was simply just the question, current chat history, and system prompt is that the memory is very short term. But when you run an AI agent system, sometimes we need extra memories. For example, how should the agent respond to the person? A procedural memory is exactly that. It basically tells the agent how to act and what are some of the instructions for the skill. We might also want the agent to know some durable facts about this context. For example, I might want to compare my own early stage startup journey with Sam Altman's early startup journey. We need this agent to have a memory of who I am, which in this context would be a durable facts or a semantic memory. Who Sean is, what did he build in the past? These kind of things become a fact that you want your agent to know, but they're not publicly available if you're not famous because the AI model won't be trained on such information yet. But if you're famous already, you can skip this. They already know who you are. And another thing we need is called episodic memory, and they include things like the past events or past chat history that does not exist in this current conversation. For example, I might suddenly be wondering, when was the last time I was preparing for a job application? And can we retrieve that information and match, if we can get a job in ChatGPT? So these things will be retrieved from this thing called an episodic memory, which is basically a time series of the previous conversations or previous triggers that happen if you have a more complex system. So for those of you who have watched my previous memory agent system design, you might be wondering, Sean, why are you repeating all of these things? And that is because if you think about the entire thing that we just covered in the past few minutes, we're really stating the one fact that a large language model can't do these things by itself. It's like a really powerful brain that knows everything about humanity, everything about science, anything that happened in human or biology history. But it does not know you. With you or the software who's running this AI agent system, a large language model has no clue with how you want it to perform. This is why the concept called harness becomes really important in this. What harness means literally is that it's a set of harness tools that you use to control a horse when you're doing a horse riding. Imagine this large language model is a horse, right? This horse is very powerful, they can run around, but if you don't have a good set of tools to ride this horse, you could just get hurt, you might go anywhere, you might go somewhere random. If you're in a war, you don't want that to happen. And that's why we're doing all of these to make sure we have good control over this large language model and make sure we're utilizing it at its maximum potential. That's why in addition to just the question or use a prompt and getting the reply, and we're feeding them all in as a working memory, which can be enhanced by these three memories we just talked about. And in order for these three memories to actually work, there's a bit more details and they're all included in harness. Remember, harness means we're building this agent framework to control this large language model so that it works the way we want. For those of you who study statistics or machine learning, you would understand that a large language model is actually predicting the probability of the next word that it should spit out. When everything comes with probability, there's randomness in it. But when we solve problems, we sometimes don't want too much randomness. So that's why we need to have a good control over this technology. Now let's continue to finish this harness. There are lots of tools on the market that's already quite useful. For example, you could try tools like LangGraph, LangChain, or Pydantic, and there are many others. In this video, we won't dive too much in depth into that, and we're gonna finish building up this harness before we move on to the next topic. So again, for this agent to work properly, we need this memory system to work, but this memory system needs an update system because memory doesn't just exist or pop up from nowhere. You need to constantly update it. That's why we need a database to store all these memories so that when the agent is running in this agent run, it knows where to retrieve these memories. So whenever you see an icon like this is a database, okay? Procedural memory is basically, remember, it's about instructions, right? It's about how the agent should be acting. It's like with a harness on the horse, you want the horse to ride faster or slower. Normally, these are just files or text, and that's why you probably heard of this buzzword called skills. Skill is basically a piece of text in a markdown file that you feed into AI agent like claw code. But if you want to harness the system well, just having files and text is not enough. And they're stored in databases, say like AWS, Supabase, Google Cloud, Azure, all these kind of places. Or you can set up your own server at home if you want, but that's just too expensive. You don't want to do that. And in order for this harness to work properly, you also need to figure out how to store the memories, okay? So for example, the episodic memory is the time series of the events that happen or the previous chat history again. The way we store it is actually very simple. You just track every single thing that happened, and then it's gonna become like a very long list of things that happen in history with timestamps. Durable facts is a different story. You can either input it yourself or you want the system to sort of automatically evolve over time. And the way for it to evolve is that you want to consolidate some of the conversations into these semantic memory. If I'm running a D2C brand e-commerce company, perhaps my customers have talked to my customer service agents for a million times about how do I get reimbursed if this product does not work. You want to consolidate these conversations and distill them as a fact into the semantic memory. And that's why here we have a little gate here. If your brand has 1 million people purchasing products from it, let's say you're Alibaba or Amazon, it just doesn't make sense and it's very expensive. So from a harness perspective, you want to be smart about this and you want the system to be automatic. And in a simple way, it's probably like maybe consolidate these time-ordered events after every, say, 2,000 conversations because you have 1 million customers. And then you can feed these things into a summarizer agent, which is another large language model harness. You can define the system prompt in this one. You can probably feed it with some memories too. You can configure different models. Maybe it could be a cheaper model because you're feeding too much text into it. So the context window is too big, and probably these are very expensive. So you can use cheaper open source models if you want to. Having such a mechanism allows you to consistently update this memory system. The data should be coming from the previous large language model replies. Again, let's review how this harness works. A user sent a prompt where in one agent runtime with the current chat history and how the agent should be performing, the system prompt, we're preparing a working memory for this AI agent to be able to answer a question. And after every single time it answered a question, it will send these messages to this database. And then this database is basically feeding back to this working memory every single time when a question is checking for relevant context. And at the same time, because this database is too big, sometimes you want to consolidate them into some summarized information or distilled facts so that they're stored properly in a semantic memory so that the retrieval of such memories is just faster. I know we talked about retrieval a lot, and that's just another buzzword called RAG, which is retrieval augmented generations. I also have a few videos explaining what RAGs are. Feel free to watch them. There's a little bit of difference between how we retrieve from semantic memory and episodic memory. For semantic memory, it's just RAGs because these are just facts and text or files, right? But then for episodic memory, remember this is a time series. Let's say we're still in this e-commerce store, right? The user question could be like, what were the previous 10 conversations that we had with this specific customer from the US? And then you might just need a SQL query to query something that's pretty recent from this episodic memory. But if your question is like, what were my previous 20 conversations that have customer complaints on the quality of the products and our agent did not successfully resolve? With such a question, you not only need a SQL query, which is just capturing the dated events in a data table, you also want to do some semantic search. And that's why here RAG is important because it's checking for relevant information for you. You don't want the entire 2,000 messages. You want that 20 messages out of these 2,000 that are exactly relevant to what you want. And because these complaints are in text, we need to do some retrieval augmented generation to match the semantic meanings between text and the user prompt so that you're fetching the right context for the working memory. By now, this is probably a fast walkthrough of the memory system again, but we're just thinking about it from a harness perspective in this video. And remember, for harness, we're training this horse of LLM to run autonomously without having too much randomness, okay? There's another piece of it that's quite important, which is the agent might not only just read the memory, it might also do some tasks or call some tools. When an agent calls tools, it might not necessarily be just one-time call. It could be multiple times of calls. For instance, let's say this AI agent has a bunch of agentic tools such as help me schedule a meeting, help me read or write my customer relationship data from the CRM system, or help me fetch the payment information, say from Stripe or Alipay. And here's something we should be careful about. If we give this horse or this LLM technology full power, it could just continuously do this forever, right? Or it might not even know what's the right time to stop or what is the right tool calls it should make. When is the endpoint to decide, okay, this response is good enough, let's move on to reply. That's why we have this mechanism called end loop guardrails. Yes, now we're talking about loop engineering, one of the biggest buzzwords in the recent few months. A loop is part of harness. Why? Because a loop is also helping us to control this technology, to make sure it runs the way we want it to run. An example that could be helpful for you is that, let's say the custom prompt is help me find out what customers are complaining about our products. What are some of the follow-ups we could do in order to win them back? And if they're asking for reimbursement, have we done the reimbursement or not? If not, can we do that? This is probably a series of questions, but sometimes we just dump all of these things into AI agent, okay? And after you have this prompt, this LLM agent needs to decide, okay, what are some of the tools that could be helpful for me to finish this task? Loop here is basically an architectural thinking of when is good enough so that we stop and give the user or the business owner a reply, okay? So what might happen here is that the LLM agent is doing a bunch of tool calls, it's doing some thinking, it's saying, let me read from our customer relationship management tool like Salesforce, HubSpot, or Automatus. And then it's going to find out, okay, there were 30 customer complaints in the past 2 months. 12 of them have got reimbursement, the other 8 have not got reimbursement. So after the first initial fetch, it's probably responded to the AI agent, right? And the agent will be probably thinking, okay, the task or the ask is that can we follow up with some of those who did not get the reimbursement, right? So, and then it probably like just make another tool calls and be like, hey, let's schedule a meeting with those customers who did not get a reimbursement, which are the 8 of them. If we go a little bit more advanced, we even just use the reimbursement trigger on Stripe or Alipay to refund the customer. Can you see that this is a loop until we finish the task? But of course, this is like a case-by-case situation. It really depends on what your task is, how you built the system. So there's no one solution fits all. Here, I'm just explaining what a loop is. The very, very essential part of this loop is that it needs to know when it should stop. That's why we need this end loop guardrails. The guardrails could just simply be the task is done. And perhaps when the agent was doing the planning, it should confirm with the user, what is a good ending point? It might clarify with you, is this what you want? Reimbursing the other 8 people, or should I just tell you who they are and then you will follow up later? Right? These are 2 different decisions you can make. And after you make, you're basically telling the agent loop that there's an ending scenario. Another good example I saw today is that, when you're doing coding and Claude Code can just always pop up some windows and ask you for permissions, right? So a good way to use a loop engineering here is that you can set up a loop or set up a hook in Claude Code and telling it that you should always send me a notification on my laptop if you are pending on some permissions from me. Otherwise, if I'm watching YouTube and then when I come back 30 minutes later, I realize that Claude Code is stuck in that one permission like 25 minutes ago, that would be a waste of my time, okay? So you can set up a loop like this to make sure that there's a way to send you notification pop-ups so that you know the loop has ended or it needs your input again. Are you guys still with me? Good. So by far, we have covered AI agent run with a memory system, with a loop engineering around the large language model agent, which has a trigger to end the loop so that it sends a reply to the user. And basically this whole thing is an AI agent harness system. What's next is one of the other biggest buzzwords that Y Combinator always mentions, which is eval or LLM ops. Let's jump into it. But firstly, I want you to understand, why do we need LLM ops here? Let's still look at the left-hand side with this harness system. The biggest problem here is that we don't know how well it's performing. And that's why we need a feedback loop to help us understand, is this agent actually performing properly, right, for my business or for my use case? And can I continuously get feedback on how do we fix it and actually fix it ourselves, okay? And when we say fix it, a simple way to understand it is that, can we have a better system prompt? Can we have a better large language model configurations? Is there something we should change for how we retrieve the AI agent memories? These are kind of things that we can continue to iterate. But in order to iterate, to make sure this system runs properly, we need a way to evaluate it, diagnose problems, solve the problems until it's a healthy and well-performing system. And that is called Large Language Model Operations System, LLM Ops. So again, in order to understand this properly, we need to come back to what an agent run is. So an agent run, you can simply understand it as a user question is sent to a large language model and then you get a reply. That is one agent run. But in this agent run, the agent tool calling could happen multiple times. That does not matter, right? We're just talking about from a user input to a response from agent perspective. That's one agent run. And then we're going to introduce this system called a tracing system. So every agent run, we should trace like a tree of events that happened. And there are lots of tools that could help you with that. It could be Landfuse, it could be Landsmith, etc., etc. A tree of events could be like, what did the person actually ask? What retrievals did the model actually retrieve? How many times did the large language model actually call the tools? And how was the tool usage? How was the response time, right? How long did it take for this entire system to run, for checking latencies? And how many tokens have we used when we do these tool calls, agent run, doing this retrieval augmented generation, these kind of things. So trace is helping us to track events, basically. And that's the first step. This is the step first to collect data. And these data will be used for the following two purposes. Was it a good system run? And was it healthy? Which corresponds to evaluation system. We can probably use large language model as a judge here to give us a score on how well it performed. For example, if the task had something to do with scheduling meetings, did the meeting actually trigger? How long was the response for an agent to reply to a question? Was it 20 seconds or was it 2 milliseconds? And also things like how many tokens have we used? These two are basically in the same system. You can write it as deterministic code, you can use an AI agent to do it, but this is like part of the procedure, which is helping us to understand, was this a healthy system and was it a good system? And after that, we're gonna diagnose, okay, where and why something was broken. For example, the meeting scheduling event was never triggered. Why was that, right? We want to understand why was that. And we could probably feed that into a coding agent in Claude to sort of deep dive into it. Or, if the latency is 20 seconds instead of 2 milliseconds, something's wrong. Maybe one of the tool call is taking too much time. Maybe the working memory is too large, so that the response time for a large language model to a memory retrieval is just taking too much time. Maybe not every single question requires a retrieval from all these gigantic memory system. Maybe you're just asking a simple question, be like, when was my birthday? When was OpenAI started? And these kind of information, you probably don't need to do a ton of retrieval. The model itself already knows. So you basically want this system to provide a dashboard for you to understand the metrics. And then with these metrics, you can diagnose what is going wrong. And then we're gonna have a little gate here, which is if the evaluation system passed, well, you can define the rules. We can either ship some very simple fix, have a new version of the prompt, or update the model configuration, some tool changes or the parameters for retrievals. The LLM ops will feed the improved system prompt and the configuration of the model back to this agent run system. Then one LLM ops loop is finished. If, let's say, something is deeply broken, right? We cannot just simply ship the latest version of the prompt. Then we should go fix the bug, rerun the agent run, resend the question, and then retrace the events, and then redo this evaluation system in this LLM ops architecture. So now let's zoom out and look at this chart one more time. We covered what an AI agent run is, we covered how it would retrieve information from memories, and we understood how an LLM agent would ask questions, would call tools to help it finish the task in a loop, and it knows when to stop the loop so that we can get the reply. And this whole thing is a set of harness tools that we're controlling this horse, this technology, to run in the right direction, okay, to do the right task. And at the same time, we have like a health checking system or evaluation system to understand how every single run is being traced, is being observed, and how do we diagnose some problems and fix some problems and ship the latest updates of the prompt about the model configuration, about all these parameters or knobs that needs to be updated, so that this system will be an autonomous system that will just self-evolve and grow over time. I really hope this was helpful. Let me know what you think, and if you have any questions, you can always reach out to me. I'll see you in the next video. Thanks so much. Hi everyone, this is Sean. So today we're going to walk through Hermes Agent Harness and its loop engineering system. This is one of the most popular harness agent system right now, and it's an open source project. If you check their GitHub, they've got more than 200,000 stars in a very short period of time. So it's basically a self-improving AI agent built by this research lab called New Research, and it's a built-in learning loop. It creates its own skills from experience instead of you telling the AI, like Claude Code, to make skills. And then it also improves over time when you keep using it because it persistently stores knowledge in your local machine, like your MacBook. But anyways, this is all the buzzwords. We're going to jump into this Hermes agent system design like usual. We're going to test it as well using their desktop app. Just give you a quick example. It's like a Claude Code, right? You can see that it was thinking and then it answered me in like a Pikachu style. It said, Pikapi, just hang out in my directory because it's literally a bot living in my local machine files. What we're building, fixing today, Pika Pika. And also you can interact with it on WhatsApp and then just say, good morning. It's a little bit slow. I'm using a Gemini 3.1 model for this. It took like a good 5 seconds. And now it's basically just using WhatsApp as the gateway to receive information from my WhatsApp account. So I can just text it and then ask it to do things for me and say, Pikapi, good morning. You probably realized that I've changed its personality a little bit and there are more interesting things I can show you. For those who have watched my previous agent harness, loop engineering, and memory system, you might realize that this chart is somewhat similar. This is what the previous chart looks like. And now if we look at harness for Hermes agent again, I added a a bit more information, especially the difference between the Hermes harness versus a generic harness system. I marked the differences in red, but we're going to walk through this step by step. Also, I prepared some testing examples to cover harness, memory, skills, loop, gateway, and LLM ops or eval, because a lot of people were asking me if I could implement some real examples. So here we are. Without further ado, let's jump right in. Okay, so firstly, let's look at the foundation of Hermes harness agent. It's a harness that runs on your local machine. You can use either local command lines, Docker, SSH, or a virtual VPS. There are two main ways to interact with Hermes agent. One is using your favorite communication apps, and in my case, I used WhatsApp. Or you can just use their desktop app with the Hermes agent. So you can come to Hermes official website, hermes-agent.newresearch.com, and just click on download for Mac OS. Or you can click on Windows over here to use the command line to install it. Essentially, it's still a chatbot, just like Claude Code. And you ask the question to either the communication app or the desktop version. It's very similar to OpenClaw, where you can use WhatsApp to control it. So after users send the prompt user prompt with the current chat history and the system prompt will be fed into working memory. And then this LLM agent is basically the Hermes agent that will be answering your question. And it will be using a loop engineering over here to call up some tools that are only on Hermes. And eventually, after it finishes the task, it's going to end the loop and then send the user a reply. Just literally sending a question throughout this entire ephemeral agent run and then get the user reply. Just like my Hermes was greeting me like a Pikachu. And by the way, how did this happen? Right? I'll show you right now. So the system prompt for Hermes is interesting. It's called soul.md. I really like how they name it. It says soul. If you come to the right hand side, you can see there's a little file bar and this is your local files. And you can go find out there's a .hermes folder. And we open that. And if we scroll down, you will see there's a file called soul.md. Double click on that. And you can edit this yourself, right? But since I've already edited it, after you edit anything, you can just click on save. I basically say you talk like Pikachu. Every reply starts and ends with Pika, Pika, Pika P. If you're excited, say Pika P with the lightning. If you're sad, say quiet Pika. I'm pretty sure you can do something similar in Claude Code for this. In Claude Code, something similar will be in customize, general, and you can see there's an instruction for Claude. You can tell Claude to do certain things and not to do certain things. It's basically the system prompt used across the entire agent harness. If you didn't watch my previous video on harness and loop engineering, harness is basically a set of tools that allows you to control over this really powerful horse, which is the LLM itself. In our case, the LLM we're using is Gemini because I've got the Google credits. I don't want to burn my Anthropic credits, but feel free to use the Anthropic. This is the agent of the horse. And the harness is this entire thing. So it's like a horse harness that you ride on and you make sure that the horse is not going anywhere random and it's using the tools accordingly to move in the right direction. Harness is a very vague concept. Just don't fantasize it. It's nothing complicated. It's just a buzzword. Then we're going to continue to build up this harness right here for Hermes. But what I'm going to show you is what a loop is. The concept of loop got really popular because these days people build a lot of agents. You don't want to always tell the agent what to do. You want the agent to figure out what kind of prompt you should send, what kind of tools you should call. Let's take a look at what tools Hermes agent actually have to enable this loop engineering. We're going to cover this briefly and then I'll show you real examples. So first of all, the agent of Hermes is having a set of tools that include the terminal, the browser. Okay, you can use your laptop's terminal, you can start a browser, you can delegate tasks, which means that you can spawn up some sub-agents for you. For example, you can ask it to spawn up an agent, which will call your Claude Code, CLI, to write code for you if the task is basically fixing some bugs on my GitHub. And then it can schedule a cron job. A cron job is basically, it can schedule something that will happen at a certain time. You don't need human intervention to do it. For cron job, let's just try it right now. In Hermes agent, I can say, help me set up a cron job that will tell me a Pokemon joke every minute in the next 10 minutes. Okay, I'm just gonna send this. And also, I'm gonna send this to our Hermes agent WhatsApp interface too. And instead, I'll just say, tell me a developer joke every. It just quickly called this a cron job. And it says, it repeats 10 times for the next 10 minutes. Because it says it's hanging in the terminal UI, it won't be able to print it. So I need to ask it. I just ask, like, what's the first joke? And you can see on WhatsApp, it also got scheduled. The cron, it says the joke machine is powered and scheduled. I've set up a cron job to send you a fresh joke every minute in the next 10 minutes. You should receive the first one in about a minute. We'll see about that. Okay. Why did the Squirtle across the ocean to get the other tide? Pika pika. Okay, so that was cron job. You can do skill management as well. You can connect to MCPs as well. It depends on the question that the user asks. The agent will just leverage these tools until it's done, and then it will send a reply to you. Okay, the example we just saw was cron job. I'm going to show you some more examples later too. Let's test a few harness and loop examples. The first one is use a terminal tool to find out what OS version I'm on and read the last 10 lines of my shell history. Let's do that. Let's start a new session. I'm just gonna ask this exact question to it. So you can see it ran this on my local machine, and then it figured out that I'm on Mac OS 26.5. And the last 10 lines I used in shell history is basically text, get status, get status, get status. I always like to check get status. And here what happened was that it ran through this agent run, and then it called the terminal to do the task for me, which is checking what system I'm on. This is a very simple example, but you can do more crazy things. You can ask it to use the local machine terminal to do things for you. If you're using Cloco, you're very familiar with this already, all right? There's nothing special about it. I'm just showing you the example that this is a harness and there's a loop, because after I fetched it, it will stop and tell me and reply to me. Let's look at the cron job as well. You can see that it sent me 2 jokes already. Why do Java developers wear glasses? Because they don't see sharp. Pika pika, I would tell you a UDP joke, but I have absolutely no guarantee that you would get it. I'm not going to wait for acknowledgement anyways. Pika. Okay, this one I didn't get it. So one more example. Browse the YouTube channel, Sean's AI Stories. Title plus views, my last videos. Create new video titles for this current video I am filming. So here we're asking it to use the browser basically. Okay, you can see that it started doing the searching. All these things already exist on Claude Code. I'm just explaining it from a system design perspective and showing you examples, okay? And then also I will show you what's the difference between Hermes and Claude Code. So please bear with me. All right, so I need to run a Python script. So you can see it also use some clicking tools. Oh, there's an error. The website was wrong. Try this new one. It saved a little memory here, okay? It said user profile updated. This is something I'm gonna cover in a bit, but spoiler alert, Hermes agent will save agent memories by itself. It's basically in your local files too. If you come here within the Hermes folder, if you scroll down in memories, you can see there's a memory.md. If we double click on that, it's stored YouTube here, YouTube scraping quirk. So because it realized that it had a mistake, so it updated itself with the memory. This is a self-iterating process of this harness. Good, so it read my previous YouTube titles. It realized that I've got this video that's got 100,000 views. And since I'm filming a new video now, it gave me some new titles. So what happened here was the user, which is me, who asked the question through the desktop. And then it went through this agent run, and then this agent harness Gemini that I'm using was basically calling the browser right here to search up my YouTube channel. And then it came back and said, hey, I didn't find anything. So it basically stopped. There's an and loop guardrail. The guardrail stopped and said, I didn't find anything. So I realized that, okay, the previous URL was wrong. So I input it again. It called the browser again. And it also called the terminal to run some Python script because it needed to do some task. And eventually it came back with the answer. There's a mechanism that says, okay, end the loop, no more tool calls, and then send the answer. These are 2 quick examples of what a harness loop engineering is. You see, you're already using it every single day. It's nothing fancy. So don't get overwhelmed next time when you hear these terms. It's just a buzzword. So what happened just now was this memory.md that we saw regarding YouTube memory. Hermes agent, after or during the agent run, it's gonna start to create its own skill.md and memory.md, depending on if it's feeding into the procedure memory or if it's feeding into the semantic memory. And we should add one more arrow here, basically. So essentially, the way that Hermes agent works is that it's storing its own skills and memories completely locally. Nothing's stored on the cloud. It has its own self-improving loop. Every time when it realizes that something is a mistake that you should learn from, or it's a repeated task, it will start to summarize, okay, here's some new memories I should know for the future in order to serve this user well. It started to save these files into these 2 chunks of memory system. The first one is called procedure memory. It's basically how you act, how the horse agent should be acting. And then it's usually saved in this directory called Hermes skills, skill.md. Hermes skills and any of these, okay? Autonomous AI agent, Claude Code. There's a skill for how Hermes will use Claude Code here. So it will basically delegate any coding to Claude Code CLI, shows exactly how you should do it, like install Claude, run it, and do the authentication and all these kind of things. And then what we just saw earlier was memories. The memory.md is saving the semantic memory, which are some durable facts or things related to the user profile. So if the user has a habit or has some important facts or information you should remember, then it will be saved in the memory.md. And what's interesting is that for Hermes, instead of doing the embeddings, it's actually just using plain text. Okay, it's using the Topk keyword instead of doing the embedding or the RAG system. It's very interesting because I'm not too sure why, but it's just doing text. So remember that we say the agent run is ephemeral. Now that with working memory to be fed into the agent for all the loop engineering, which includes procedure memory, semantic memory, and later we'll cover episodic memory, this will become a more complete memory system that will feed into the agent runs, which is making the harness more elegant. And the third pillar that we haven't covered is called episodic memory. It's basically the chat history or some dated events. It can be racked or sequeled into the working memory. After every agent run, the information will flow into the episodic memory. What's different in Hermes is that the data is not saved in the cloud. It's saved in this place called state.db. Again, let's come back here. On the right-hand side bar, if we again open Hermes folder, scroll down, you can see at the end there's a state.db. And I can click on preview anyway. This is basically a database that will include all those info in your chat history. But also over time, it will start to consolidate some of those chats using the Hermes auxiliary models, which are cheaper, non-important models, to do this summarization task so that it will distill some facts into what we call the semantic memory or the memory.md. So you can see this harness is running really in a self-improving autonomous situation, which is really cool. I know this chart is getting more complicated than usual, but I feel like this should be a complete summary for how the Hermes agent works. And let's go through a few more examples. Let's test out some of the stuff for memories. Save to memory, that my favorite testing framework is PyTest. So this is an explicit saving, right? It updated the memory file. So if we go to memory, you can see one more block, which is user's favorite testing framework is PyTest. That was an explicit ask from the gateway. The tool is basically, let's go update the memory over here. Search our past sessions. What was the very first thing I ever say to you? Now it's using the searching tool in the loop engineering iteration. Say the first thing I say is, what can you do, Hermes? And what makes you special? Let's double check that. That's right. And it failed because I couldn't log in at that time. So what happened was I asked a question through the interface. It went through the prompt, and in the working memory, because we asked that, so it queried the information from episodic memory from state.db. It returned the memory into the agent. The agent was like, oh, okay, this is what you said. Let's try an example related to skills, which is procedural memory. So we're going to say, create a skill called video prep that captures how I format my video scripts, spoken English, define jargon inline, no M dashes, closes with you can build anything, you can learn anything. This is an explicit call to update the skills. It used the skill management tool. Remember, in the loop engineering, there's a tool called skill management, and this is what it did. And say, Pikapi, I have successfully created a video prep skill. Let's find out about it. Again, Hermes, skills, media, video prep. Double click. It created this skill for me. It says no M dashes, spoken English, define jargon inline, catchphrase, you can build anything, you can learn anything. Good. So we can test the loop a little bit more. So we can say use delegate task to spawn two sub-agents. One is researching the LM eval harness, another one researching VLM architecture. The agent was calling the tool called delegate task and successfully spawned two background agents. So you can see it's processing right now over here. They're working in parallel. Cool. Eventually return the results to me. So you can see that it spawned up some sub-agents to do tasks for me in parallel. We've already tried the cron job, and the next one is spawn sub-agent that uses Claude CLI. This is my favorite. So this is my favorite. Spawn a sub-agent that uses the Claude CLI in headless mode, basically using Claude to build a Python script, fetching the top 5 Hacker News stories to Markdown and verify it runs. Yep, it firstly delegated the task to Claude CLI. It's using the skill, you can see. Remember we read the skill here in Autonomous AI Agent Claude. It should be reading the skill. Is this helpful? Let me know if this is helpful. I mean, I was trying to show you more examples in the walkthrough so that it feels more concrete because a lot of people were asking me for implementations from my previous videos. And I feel like Hermes is a really good example. Okay, it created this code for me and it used the Claude. I created the fetch hackernews.py. I just say, show me the result after running the script. Yep, so these are the top 5 Hacker News stories on Hacker News. Let's come check, it's correct. Remember what happened was that we sent the question from the gateway, it went through the agent run, and the LLM basically called up the tool called delegate task. Delegate task delegated the task to sub-agent, and the sub-agent was running in Claude code, and Claude code wrote that script and sent it back. And then this agent ran the script again, and then we get the results. This was the harness and the loop engineering in this entire thing. I don't think it's self-triggered self-learning skills yet. It only triggered learning the memory. I'm just gonna ask it explicitly. Did you save any skills by yourself, or did you only save memory so far? Oh yeah, but we created that. But we created that skill. You did not self-realize you need to save skill. You should proactively offer to save a skill after a difficult iterative task with 5 or more tool calls. So far, we haven't done anything difficult. So we can test the gateway. I can summarize what we worked on today. This Chrome job failed. It didn't tell me 10 jokes. It only told me 2. What were the rest of the jokes? Don't lie to me, because maybe you just created it. Anyways, Hermes team, if you're watching this, your cron job is not updating it unless I ask for the results. So maybe this is something you guys can fix. All right, let's move on and summarize what we worked on today. Because in this current chat, it doesn't know the rest of the stuff here. So let's see if it's calling the actual, remember we say statedb, memory.md, and skills.md. Good, it actually knows, okay? It says jokes on demand, system check on the OS version, which is what we did. YouTube stats, yes, we did that. Hacker news. Okay, good. WhatsApp here is just a gateway as an interface. It's doing the same thing as the Hermes agent desktop. This is very cool. This is similar to OpenClaw, but still every time when I feel I can just have a personal assistant handy on my WhatsApp, this is really cool. And imagine if I host this on a virtual machine and it runs forever. I can just basically ask WhatsApp what's going on, and it's gonna reply to me. Oh, I completely forgot. You should set up WhatsApp by typing in Hermes WhatsApp and then just follow the instructions to set it up. Should be straightforward. Last but not least, where is eval? Right? Where is our LLM ops? Remember in our original chart, we had this blue box on the right-hand side called LLM ops. So unfortunately on Hermes, based on my current research, I don't think it has an LLM ops or an eval system. You probably need to build it yourself. But it does trace the run. There's a thing called trajectory export and logs. And it's basically just logging the whole thing. But there's no eval. If you watched our previous video, the eval is basically you can use tools like Linesmith, Linefuse, and all these things that can track the entire agent run and some events that happen, like tool calls. How many times did you call LLMs? Did you use some cheaper models to summarize things into your semantic memory? Unfortunately, Hermes doesn't do that. I'm curious why. Maybe because it's a local system, so you can just customize it yourself. It's under Hermes. You can click into logs. You can see all the logs here. You can see the errors. You can see the agent runs. Gateway logs too. Gateway is the entry point, which is WhatsApp or this desktop. I hope this was helpful. I think there's quite a huge amount of work that we covered today, which are exactly what Claude Code can already do, or OpenClaw can already do. I feel that what makes Hermes special, at least compared to Claude Code, is that it's self-updating all these things locally. And maybe this is good for privacy reasons, because I don't see why we should not save it on the cloud. Other than that, everything else should be very similar, right? It runs the loop every time when the agent needs to do some task, kind of call all these tools, and you can even schedule a cron job. And then the memories and the skills are getting auto-updated into the procedure memory, semantic memory, and the state data will be saved into the episodic memory. So I would say this is a pretty standard harness for an agent implementation. Nothing too fancy, but I'm sure they did a ton of work. But I feel like this is a good example for how builders these days should be building products, because this is becoming a standard, right? Every AI agent tool should be self-improving and self-evolving, and depending on the user request, you can either keep it local, you can keep it on the cloud. That's up to you. I feel like the skill and memory accumulation is probably the most valuable thing in this, because the user kind of just over time get locked in and it remembers who I am, which is why like recently I don't switch to other AI anymore. I just use Claude Code. It has a semantic memory about who I am, my company information, Ultimanis, and what my style of building YouTube videos. But yeah, I think it's a cool framework. You guys should try it out. It's really fun. Cool. I hope this video was helpful. If you have any questions, please leave down a comment. And if you enjoyed it, please give me a like and subscribe. Let me know what else you would like to watch. I will see you next time. Thanks. Hey everyone, this is Sean. So today let's talk about loop versus graph engineering. Two biggest buzzwords in AI agent space recently. I am probably exactly like most of you guys, which is I don't know how to keep up with all of these new concepts, but I still find it very interesting because whenever a new concept becomes viral, usually I'm curious about what triggered it. What I find out is that this guy called Peter Steinberger, who's also the author of this little lobster, which is OpenClaw, said that are we still talking about loops or did we shift to graphs yet? And he posted this on July 18th, 2026, which is about 13 days ago. and he got 3 million views. And look at this first comment. It said, "Bro, stop. I am on vacation." So sometimes, these important people in the space who mention a keyword, and then everybody's going to start talking about it. I remember exactly something like that in context engineering. And for today, this video, we are going to demystify all of these core AI agent concepts, and especially on loop and the graph. We're going to jump in a little bit on the system design real quick. And at the same time, we're also going to walk you through a real coding example called Waku-agent, which is under my GitHub, Shanshong Chen. And we published this about 2-3 weeks ago, and we got more than 700 stars. If you think this video is helpful for you, please give us a star, give us a like, and that would be very helpful for us. With Waku-agent, you can launch a dashboard like this, and you can just ask something like, "What's up on my Google Calendar on Thursday?" Right? And then it's going to check what kind of graph it's going to use, decides if it needs to retrieve some memories, and then eventually decide, what kind of tools it should be using. Right here, it's listing the events from my Google Calendar, and eventually send you the reply. And it did a bit of a testing in the eval system, and then it spit out gave me the final answer for the results. I'm going to talk a bit more details into this, but without further ado, let's get started on the system design. First thing first, I want to talk about the AI agent engineering ladder that we have come across over the past 3 years, because I think that helps us to kind of understand where we came from and where we're going. The first one is obviously prompt engineering. And to me, prompt engineering was the very first or early version of how people start to get used to how to use an LLM. I feel the most accurate word to describe this was role-playing, because at the very beginning, we didn't know how to use LLMs. We had ChatGPT 3.5, and we tell it, "Hey, you are the best poet, like you're Shakespeare or Li Bai, right? Write me a poem about this scenery I'm looking at right now in Switzerland." Then it's going to pretend that it's one of those poets you just mentioned and then talk to you back, right? That was prompt engineering. You basically draft the prompt so that you control the LLM to talk to you in a certain way you want. And then we quickly evolved into what we call context engineering. And that is because when people move from just playing with LLM as a consumer product to actual workflows, you realize that you not only need prompt, but also you need to feed in data. For example, if you build a customer service chatbot, or if you build a sales agent like Automanus, which is my company, you need to really think about how do you construct the context for the agent so that the agent will be able to talk to the clients on behalf of the businesses, right? So you not only will say, "Hey, you are the best salesperson in the world. You will talk in certain ways. Do not say certain things." You also need to feed in data such as what are some of the customer relationship data people already have on their Excel sheets, Google Sheets, CRM system, all these kind of things. And you need to really put them together and make sure that the agent can accurately be fed with the right information. So we moved from prompt to context very quickly to fix that problem. And then we moved on to skills, which I think is sort of teaching the AI what kind of procedure it should follow, right? It's a procedure following process. In AI agent harness, this is called procedural memory. It's a memory that you tell a kid, "Hey, when you walk home, walk on the right-hand side if you're in the US or in China, right? Walk on the left-hand side if you're in the UK or Japan." That is a procedural memory that you want a person or you want an LLM to remember, and there's no extra data. It's just fact that it should be doing when a certain situation happens. Okay, so why do we need skills? It's because that if you provide a lot of context to the AI, sometimes it can be a little repetitive. You don't want to always provide the same order to AI again and again and again. So having a skill to determine a workflow becomes really, really handy. Just like, for example, if you're coding on Claude Code, you don't want to explain to Claude that do not use emoji, do not use emoji, do not use emoji. Or I prefer to use emoji, use these emojis, don't use the brain emoji, I hate that, right? These kind of things you have to repeatedly tell the context, then it's becoming less convenient. So you can build up skill to make sure the LLM is following that procedure. Then it comes with loop. What does loop do? A loop is basically saying, hey, maybe sometimes you have a goal and you want to finish that goal, but we don't know the exact skills you should have to finish that goal. we might tell you, hey, there are a bunch of tools you can use, right? That's why Anthropic came up with MCPs. You can call your Google Calendar, you can call your Gmail's APIs, you can call your GitHub APIs. These tools become handy, and then you're telling the LLM, be like, okay, run a loop, know your goal, which is maybe help me fix this bug that the customer come up with. Run this loop, and here are a bunch of tools. Here's a web search tool, here's a bunch of API calls, here's a bunch of MCPs. Use them. Loop it until at some point you finish the goal, and that's the end of the iteration. And then the question comes, why do we need graph? What does graph do? Because graph technically is a procedure that is predetermined. Many people are criticizing graph engineering is not new because maybe in 2023, I remember people were already using Airflow, people were using step functions, people were talking about how do we make sure that a deterministic workflow can be set up properly so that we don't just tell LLM to make all the decisions. Because sometimes we know exactly how a certain task needs to be done. There's a step there, there's an SOP there. So to me, it kind of feels like, okay, we moved from skills, which is strict procedure following, to loops, which is, hey, agents, go figure it out yourself. To eventually we realize that, hey, we need a mixture of both. That, in my opinion, is graph. Okay. Technically, sometimes you should write the skill first. Okay. How do you cross the road? On what side do you walk in the pavement, depending on which country you're in? And how do you respond to a client? How do you respond to me when I'm coding with a coding agent, right? And then you should turn that into a graph. If you see that there's a lot of repetition in the workflows, especially if you're building a workflow for a corporate, right? If you're working in e-commerce, maybe you see exactly how your customer service should be answering questions related to logistics, to a refund, to check-in samples. You realize that you can really consolidate this into a graph when the workflow stops changing. Perhaps there's still part of the workflow that you need to use a loop, where the loop is basically doing this explorative work out there, right? It's probably doing a bunch of research for you. I think deep research is one of the early examples of a loop engineering workflow here, where you just say, hey, go crazy, just go search the internet, I want to report. These kind of work are less standardized, or it doesn't have an SOP in it. It's just about, I want more information, or I have a certain goal. Use the tools available to you to figure it out for me. It's quite different from graph, because sometimes we know exactly what tools they should be using to finalize a task for me. Okay guys, that was a conceptual walkthrough of this AI agent engineering ladder. Now let's take a look at what a loop and a graph look like. What a loop does is that it discovers what to do next. So maybe this is you, and you ask a question to an LLM, and the LLM is basically saying, hey, do I need to use any tools? If yes, choose a tool, run it, and check if it finished the task, come back to the LLM, and then loop it again and again and again. Until at some point, LLM is like, hey, we don't need a tool anymore. Let's reply to the user. Examples here could be like, you are trying to fix a bug on a pull request on GitHub. You basically ask Claude Code or a Codex and be like, fix this bug, tell me when it's fixed. And it's gonna go ahead and then use a bunch of tools like web search, GitHub CLI, checking your Supabase, checking your AWS, checking your Google Cloud, all this kind of stuff. And then at the end saying, okay, we're done. Okay, and the bug is fixed because of ABCD. That is a loop. A graph, on the other hand, is somewhat similar, but it's not exactly the same. So you might have a standardized process every day and be like, oh, I want to understand how many people submitted pull requests overnight, and who are these guys who submitted some tasks. Can we take a look at them and tell me if things are fixed or not? And maybe at the same time, I want to understand, what are some of the latest news out there on AI agents, and maybe we want to do some web search as well. Maybe we want to run some, Git commands. At the same time, we know exactly how it works. Okay, and then you probably want this to be done in parallel. So you ask a question, and then it's going to check out the GitHub to check out the pull request. It's going to search the website for you to do some explorative analysis. And it's probably also going to check your calendar, plus the memories stored locally or on the cloud. And then it's going to synthesize these information and tell us, hey, is there anything else to do? If not, end this and reply. If yes, please explain. What kind of things do you still need to do? Okay, you see the difference here? So sometimes you can have some loops here. Okay, maybe having an agent loop to search the web, or have an agent loop to fix the bugs on GitHub is part of this graph. Okay, so you can see graph is basically saying, okay, I know exactly what you should be checking. Maybe they're in parallel, maybe they're happening in sequences. Do it the way I want. And once you finish, synthesize it and tell me the answer. Are you guys still with me? Let's check a real example first. Come back here. Let's come to Waku Agent dashboard. The way you set it up, by the way, is come to this website, github.com/chen/waku-agent. You can either click on code and copy this, and then type into your terminal and say git clone and paste that in and hit enter, which is this way, and you can just copy this and paste in your terminal. Or recently we released a new package in Python called Waku-agent. All you need to do is copy this, pip install the Waku agent into your terminal, set out your environmental keys, and then you can launch a dashboard. Copy this, paste this in. Because I'm already using port 777, so let's use 778 as an example. Paste that in. You can see this is it, okay? Since I already set it up, I'll come back to this localhost 7777. So what you're seeing right here is an entire AI agent harness starting from the gateway, which can be the chat of here, or you can use some other channels such as Discord, Telegram, WhatsApp, stuff like that. And then it's going to check out the retrieval gate to see if we need any procedural memory, which is skills, as we mentioned, or semantic memory or episodic memory, which are durable facts or the dated events that happened in your local memories. Okay, and then it's going to run through an agent loop using LLM agents and calling the tools, and eventually give you the reply, during which the LLM ops is going to trace the data, test it, and then release it, the new version of the prompt, and feed back to the harness. But this is the entire harness, okay? And loop engineering is happening here in this little loop. A graph workflow is basically, after this gateway, you can predefine some of the process in between here. So we have a new tab called graph. We currently have two graphs here. One is called triage, another one is called gather. For triage graph, what it does is that it's saying, okay, start point, and then it's going to classify if it requires some agent calls. And then at the same time, it might just check out my calendar and see what's going on, okay? And I can just be like, what's up today? All right, you can see it triggered this triage first, right? It checked the Google Calendar for me. And also at the same time, it was checking, if we need to have some, need to do some serious agent calls here. And it eventually decided that, okay, it's going to use some tools. So they use the list events, read the Apple Calendar for me. So you just saw a very simple graph kind of call already, okay? So what it did was that it checked, as I mentioned, if it needs some serious agent calls. And in parallel, at the same time, it was already checking my calendar because I was asking what's up today. And then after that, I used this loop to call the tools like list events, read Apple Calendar, and all these kind of stuff, and then give me the reply, okay? But what if I need to test something else? So here in this local agent harness, what I recently updated is that you can very clearly mention the workflow you built. In the graph, we have gather. So you can clearly say /gather and then say, tell me what's up with Waku agent and any new PRs, any competitive projects. Let's see what happens. You see that it triggered this graph instead, okay? Let's come back to the overview. It's showing me that it was triggering this graph. And it used these tools simultaneously, and then it's synthesizing the answers for me. Okay, so what it did was that it gave me a morning brief on what kind of PRs are out there, and we have released a new package, which you can check in this GitHub. If you scroll down a little bit, we have released a new package for agent graphs recently, and also there are some PRs to be reviewed. Okay, let's come here. So if you click into pull request, you can see there are some PRs here for me to be reviewed. And for the web search, you can see that it researched about Harrison Chase published your harness, your memory, and your own videos in harness eval R ranking. Okay, it was doing the competitive research for me as well. All right, so you might be wondering, how did this work? If we come back to the tab for graph, you can see that we clearly defined two different use cases of graph. One is triage, another one is gather, and they have very specific ways of running the agents, and they both use loops, because when it does the web search, it needs to search for the information and come back to me, right? When it does the check calendar, it's going to check the calendar until it find out what's going on in my calendar and then come back to me. Okay, these things are all kind of intertwined in this agent harness system. So if we come back to the system design, there's something interesting I wanted to show you, which is how exactly did the workflow finish from the beginning to the end from a time usage and parallel processing perspective. For the loop, an agent loop, for example, web search, is going to decide what it's going to do first, right? It's going to check out my GitHub, calling tools one by one, right? Maybe after the first call, the agent decided, okay, we need to do one more call, and then it called it again. And then it checked the calendar, and then it synthesized the information for me. But in the graph example, which is this workflow for gathering information, it used multiple tools in parallel because we already told it you need these 4 tools, right? Maybe each one of them spent different amount of time. And it did the GitHub first, and the web search did the most amount of time. Calendar check and memory retrieval did the least amount of time because it's instant, or maybe because you did not need any memory retrieval at all. And then it's going to synthesize the information because it's got a lot of context at the same time. So you cannot say graph engineering is replacing loop engineering because they're coexisting. And you cannot say loop engineering or graph engineering is better than the other one because we need them in different use cases. A loop is something you need when the model decides what to call one step at a time. A graph is something like when you know the shape and you just want them to move together. Okay, it really depends on the situations you're building for. In your local files, we have a Waku folder, and then we have a graph folder. And within the graph folder, we have defined the graph engines, which is literally a graph. And you're going to add nodes, which in our case could be web search tools, could be agent calls, could be MCPs, anything, right? And then you're also defining edges, which is, okay, where do we go after using one tool, right? After the web search, do we go synthesizing or do we go somewhere else, right? Graph, we also defined nodes, which is basically saying what kind of things can be a node, right? Tool calls, LLM calls, agent calls, router, these kind of things. And then under this graph folder, we also have another folder called workflows. You can see we have triage here, right? Remember, triage was the chart we showed you, which is it's going to classify if it needs to use some complex models to do agent calls, or is it doing some calendar checking at the same time. These two things are happening in parallel at the same time. And the close is actually very simple. You define these functionalities to make sure that the triage graph is working properly with this predefined workflows, right? You add node when you need to add more tools. You add edges by defining the initial prompt from start can go to either classify or check calendar at the same time. If we check out the gather tool as well, remember it's a similar thing as our previous chart. You can scan the GitHub, website, check calendar, memory, okay? GitHub, website, calendar, memory. These are all the nodes. And after that, you synthesize it, and then you decide if we should return the answer. Obviously, we're doing the same thing. We're building the graph here, right? We're adding these nodes, and we are adding those edges too. I hope this is easy to understand. And you can feel free to add more .py files here to make this graph workflows even larger. And in that case, I would love to work with you, and then you can feel free to contribute to this repo and be one of our contributors and submit your own workflows. Because once you submit your own workflows and it's approved, it will be available here. If I type in /graphs, it's going to tell me that it has gather, it has triage, and triage is the router. It's basically going to read the local files of these workflows from graphs, and people can use it. This will be very cool, and it will probably become a community if you guys are interested. And feel free to be our contributors. And also, if you're interested in talking more in depth of these concepts with us, if you feel you want to discuss with me about your workflows and any questions you have about system design, about these agent harness, all these kind of stuff, you can feel free to come to my personal website, seanchen.io, and then click on join over here to join our community. I'm just getting started to do this because I don't have enough time to answer all of your questions. I feel like the most efficient way is that I can host some live sessions with you twice a month so that I'll be able to answer most of your questions, and we can prepare some build sessions real time, showing you my real setup and all this kind of stuff. If you join this community, you will be assigned to a private Discord, and I will share more details there, including the original files of all of these system design charts that I built in the past in real code, so that you can sort of open it in your own Excalidraw website to learn about it. So last but not least, I think this is an important question we should ask ourselves, which is, isn't this just a deterministic workflow from 2023? What is new now is that some of the nodes that we're using right now are non-deterministic. It could be a LLM call. And at the same time, sometimes the model can pick the edge, right? The routing is the way that you're letting the LLM as a judge. Do I pick a simple model to answer the questions, or do I use a more complex model to answer this question? And also you need some guards, which a previous directional graph scheduler never did. These are buzzwords, as I mentioned, but buzzwords are viral for a reason. Sometimes it's because of famous people, sometimes because it's actually useful. So I hope this kind of videos is helpful for you. And again, if you have any questions, feel free to ask me. And I would love to answer your questions live in our community. Just come to my personal website, seanchen.io, and then there are a bunch of sources here. Looking forward to, and if you love this project, please give us a star on GitHub repo, and I would love to work with you. Thank you so much for your attention. Appreciate it.